the Technological Coordinator, and the Head of the Department of Biosystems.
Good afternoon, ladies and gentlemen. I would like to warmly welcome you all to the very first technology track of the IRSC of KDU, conducted by the newly established Faculty of Technology. Commencing the plenary session of the technology track, please let me introduce the chair of the today's session, Senior Professor Rahula Attalage. Professor Attalage completed his secondary education in Nalanda College, Colombo, and graduated with the degree of Bachelor of Science of Engineering in Mechanical Engineering from University of Moratuwa. He obtained Master of Energy Technology from the Asian Institute of Technology in 1986, the degree of Profound Studies in 1988, and doctoral degree in Energy Engineering in 1992. He joined the Department of Mechanical Engineering, University of Moratuwa as a senior lecturer in 1993 and was promoted to the position of professor in 2003 and the post of senior professor in mechanical engineering in 2011. Professor Attalage is not a new person to KDU. He was once a visiting professor as an external examiner of the Faculty of Engineering. To mention a few of his contributions to the academia and industry, he was a chairman in the National Institute of Fisheries and Nautical Engineering, member of the Board of Directors of Sri Lanka Transport Board, consultant in developing many mechanical engineering degree programs. He is the Secretary of Lanka Association of Building Service Engineers, past President of SLEMA, a corporate member of IESL, a fellow and a council member of the National Academy of Sciences, and a member of Research Advisory Committee of the National Science Foundation. He is serving in the university system as an academic for more than 25 years and currently serves as the Dean, Research and Graduate School in Sri Lanka Institute of Information and Technology, Malambe. Prof. Rahula Attalage is a distinguished academic and active professional who contributed broadly in the academic horizon, both nationally and internationally. So without taking much time, let me warmly welcome Professor Rahula Attalage as the chair of the plenary session to the head table. Thank you.
A very good afternoon to all of you. Thank you for the kind introduction. And I am deeply honored and privileged to be invited to chair this plenary session on technology at the International Research Conference 2022 of the Kotalapal Defense University. And this International Research Conference has been consecutively held 15 times, and in some of the occasions I have participated, and it's happy to note that year by year the evolution of the conference in terms of quality and the scope has been remarkable. So I would like to, at the beginning, congratulate the organizing committee and the institute for its remarkable performance in terms of conducting this conference. And as we noted in the plenary session of the keynote speaker, who indicated that for the development of a nation in the current context, the innovation would contribute to about 55% of its effort, meaning that looking at the current context of the country's situation, to come out with the current situation and revitalize our economy, science, technology, innovation would count a lot. And I believe with that positive note, the plenary session on technology will have some element to deliberate that will carry as a take-home message for all of us, and also extending that to the community at large to be able to contribute towards revitalizing our economy, which we had been quite good in the past, but not really in the recent past. So let us work together. And with that simple note, I am honored to take control of these proceedings. And for this session, we have lined up 4 presentations made by eminent personnel, academics, professionals in this area, technology and engineering. And 2 of them are from Sri Lanka and other 2 are international. And I will be introducing them in detail according to the lineup of presentation. But at the outset, I would indicate their names and affiliations so that you will have an idea of the lineup and the presenters' names. The first would be by Dr. T.A. Piyasiri, former Vice Chancellor, University of Vocational Technology, UNIVOTEC, Sri Lanka. The second presentation would be by Engineer Heminda Jayaweera, co-founder Jendo Innovations Private Limited, Sri Lanka. Third and the fourth would be international presenters. I believe that they would get connected to us through online mode. Professor BHW Hadikusumo, Professor, Department of Construction Engineering and Infrastructure Management, School of Engineering and Technology, Asian Institute of Technology, Thailand. And the fourth presentation would be again online by Dr. Nutthachai Prongmanee, Assistant Professor, Faculty of Science and Engineering, Kasetsart, University of Thailand. So these would be the presenters who would be making their presentations as lined up. And as at the outset, I am told by the organizers the rules of the presentation. Each presenter will be allocated a 25 minutes time slot, am I right? 25 minutes. And there would be a signal at probably 3 minutes before the end so that the presenter would know to wind up and conclude in 3 minutes time. And at the end of all 4 sessions, we will have a 20-minute question and answer session where the questions from the audience and also from the chat box that will be channeled to the platform, I believe, by the organizers. So we will have a very synthesized session with 4 presentations and also 20 minutes Q&A session. And without further ado, let me start with introducing the first presenter for the session. It is my pleasant duty to introduce Dr. T.A. Piyasiri as the session speaker to make the first presentation. Dr. Piyasiri has contributed to the technical and vocational education reforms in Sri Lanka through planning and regulation and the establishment and implementation of the National Vocational Qualification NVQ framework. Propagation of NVQ courses in areas of labour market demand, their quality assurance and competency assessment for certification were major areas of focus. As the Vice Chancellor of UNIVOTEC, he provided vision and leadership to expand learning opportunities in several areas of technology to earn degree qualifications for those students progressing through technical and vocational education. And with that experience, and also to add that, I know that he has been a long-standing faculty member of the University of Moratuwa during the period where I was also part of the team of University of Moratuwa. And I would like to cordially invite Dr. Piyasiri to the podium to deliver your session.
Degree programs were accredited according to the Sydney Code. And then the key catalyst for thinking of a technology degree program is the offer of 40,000 government jobs for unemployed graduates in 2008-2009 period, and the public and industry reaction urging to find sustainable remedies, because the graduate unemployment was a key issue and the government wanted arrangement so that the graduates will be employable in the future. So that was the thinking to have a technology stream. Then the initial discussions in 2010-11 period, the curriculums are prepared for advanced level, and in 2013 the technology stream was launched. This is a very quick process when you look at the general education reforms. You know, getting a new stream, advanced level stream in 2 years is a remarkable time. Because generally the general education takes 5 to 6 years planning time to introduce a new stream, right? And then the university degree programs were started in 2016 and 2017, that period. The overall objectives of establishing the technology stream was to human resource development in areas of technology at upper secondary and higher education levels for technological and economic advancement. We wanted to bring the more technologists and to create jobs as well as to work in the industry. Then to vocationalize part of upper secondary education for students to enter employment and or technical and vocational education. Now when you look at general education, we have the vocational subjects. We have the practical and technical skills from grade 6 to grade 9. Then from grade 9 to grade 11, we have the technology subject, one technology subject, right? There are this basket of 8 or 9 subjects, and they have to take one. And then there was none after that. So that is why this was brought to the advanced level. So it vocationalized part of the general education and prepared students for employment. And the necessary practical skills were given. So that is why the technology subjects, either it is engineering or biosystems technology, we have a practical component. The 30% of the marks at the GC advanced level examination is given for the practical tests, right? Then reduce the proportion of students entering higher education for arts and humanities. So that is an overall aspect, so that we have a higher proportion of science, technology, commerce and all that, reduce the number of art students, proportion. Now these are the figures in 2015, that is the last batch without technology stream. Art stream had 32%, management 19.59%, science 48.02%. And in 2020, because in 2016, the technology stream students were admitted first time. Now when you look at the 2020 figures, the total intake has gone up from 25,000 to 41,000, overall increase in all the fields. But when you look at the proportions, art stream has now come down from 32.39% to 26.55%. Management and commerce, 19.59%, it has come down to 18%. So the science has come down from 48% to 46.61%, and technology, the number of intake is in total it is 3,396, and it is 8.51%. Right? So when you look at the total UGC university intake, 8.15% is now going to technology stream, and the art stream students have come down from 32.39% to 26.55%. So the overall objective of establishing the technology stream has been achieved. Right? So though there is a slight decrease in the percentage of science students, right? But we have now, when you put science and technology together, much higher numbers. Fine. Now you can see the numbers, right? So you can see 8.15% is now going to technology. This is the UGC numbers without KDU and other places, right? Okay. Advanced level background of students. The science for technology is taken by all. Then they take either biosystems technology and engineering technology. Then one optional subject out of this basket. And these subjects are chosen so that they either contribute to the learning of biosystems technology or engineering technology as supplementary studies, or it creates innovation among students, or it gives a secondary subject area for them to study. So these are some of the considerations in selecting these 11 subject areas. And what are the popular ones? The popular ones are English, ICT and agriculture science. Right. The 3 degree programs offered in the technology faculties now, in Bachelor of Engineering Technology, Biosystems Technology, Information and Communication Technology. The role of the Standing Committee on Technology Education at the UGC, because when these degree programs were established in 2016, there was not much clear idea as to how these degree programs are to be formulated. They were started under the faculties of science as a department, so there was not much prominence from the universities also, and the people had to find its way, how to, we look at the design, the degree program. So, but finally, the UGC decided that we form a standing committee for technology education separately. Then after that, the things got much better, and a lot of thinking went on. And over the next 2 to 3 years, the sort of degree, what is the focus of these degrees, what accreditation requirements we would consider, and all these decisions were taken. And it is to be a level SLQ of level 6 degree, and likewise the things moved forward. And the standing committee played the vital role of designing technology study programs. UGC policy on technology degrees, it's a 4-year professional degree, SLQ of level 6, and must comply with the qualification descriptor, level descriptor, and the volume of learning, that is 120 credits. The technology degrees are to be accredited by respective professional body. ISL was there for many years, and they had the Sydney Code accreditation manual out in 2013. So we took guidance from that. Then Information Communication Technology, Computer Society of Sri Lanka, according to Solar Code, they had guiding documents by the time that we formulated degree programs. So they gave a specimen curriculum and all that. Then Biosystems Technology did not have any professional body, and we looked in several, in Sri Lanka, there's nothing, and we looked at in the near countries, and there was no professional body. So finally we decided we form our own. This National Biotechnology Industry Association was identified, and necessary support was given, and with Sri Lanka Accreditation Board, they formed the accreditation body, the certification body, and the basis is ISO 17067 now. The degree programs offered by the faculties, so there are 12 faculties altogether under the UGC. Then we have from KDU, and Gampaha Wickramarachchi New University also has a technology faculty. And under the UGC, these are the specializations offered in these faculties in engineering technology. I did not put biosystems technology here. Colombo, Jawadanapura, 6, right? Kalania, 3, Rona, Wayamba. Wayamba has materials and nanotechnology also, Rajarata, Jaffna, Sabaragamu, and Uwabellas. So these are the specializations of wide variety of specializations offered in these faculties. And how do we design these degree programs? The international basis is the design of engineering technology degrees programs in the International Engineering Alliance. The graduate outcomes exemplar, statements and professional competencies relevant to Sydney Accord. So this is the international norm for the design of engineering technology degrees. There are 3 accords. We have the Washington Accord, that is for engineering degrees. We have Sydney Accord for engineering technology degrees, and we have Dublin Accord for engineering technicians. And so the Engineering Alliance, International Engineering Alliance, it has 2 broad guidelines. One is the Accord Program Profile, where it identifies the knowledge profile and the graduate attribute profile. The graduate attribute profile is what the industry wants and the industry expects from the graduates to have. Then it has the common range and contextual definitions, giving the range of problem solving and the range of engineering activities. That gives the breadth of the program. Right? The range statement, where it will be applied, and giving the breadth of the program. The general definition for the role of a technologist, This was formulated by the UGC Standing Committee. Anyway, it is to earn recognition from the professional bodies. And it is set as managing and maintaining applications of current and developing technologies in the field of engineering technology and biosystems technology in accordance with respective recognized principles with professional responsibility and undertake functions involving design, development, planning, manufacture, construction and operation of products or systems and providing related services. So that's the main key is the managing and maintaining applications of current and developing technologies. That's the key phrase. And I have put the role of the engineer as given in the IESL as the reference, the role statement for an engineer for comparison purposes. You can have a look, right?
You see, 5 minutes.
Right, okay, right.
Thank you.
Then the engineering related occupations, we look at what is the present structure, engineer, engineering diploma holder, engineering technician, and the future structure will be engineer, engineering technologist, engineering diploma holder, and engineering technician. And this is the structure practiced in many developed countries. Where will they gain employment, these technology graduates? Private and public industry sector. The small and medium industry sector is the primary focus. Because when you look at Sri Lanka, the largest sector is the small and medium industry sector, where they need the technologies to be brought in, new technologies, the new competencies to be brought in. Then the large industry sector to a certain extent, because it is very unlikely, and it's not happening now, it's very rarely an engineer goes and works in the small and medium industry sector, but that is the sector that really needs technology. So our main focus is that. Then the government sector services where any graduate can apply, because any graduates, there are many services in the government sector, as well as in the corporate bodies. The self-employment and also foreign employment. The technology programs are to be based on this outcome-based education, and this is just the framework I put in, the objectives, how we look at from the top to bottom approach, how we design a program. We first look at the program objectives, then we look at the graduate attributes, what does the profession, industry and society want from graduates, the program outcomes, what will your graduates be able to do to demonstrate their graduate attributes, then module learning outcomes, what will students learn on individual modules contributing to program outcomes, curriculum, what, when and how learning activities will and assessments take place. Then when you look at this accreditation manual, you will find this IESL manual gives the program outcomes, 10 program outcomes in the Sydney Code, and we need to comply with that. But then the criteria for accreditation of degrees, the main criteria any professional body looks at is the structure of the academic program, curriculum components, syllabi, laboratory design, field and project work, and industrial training. How your academic program is, academic staff and students, the quality of students as well as the quality of academic staff and sufficient numbers, the teaching facilities such as classrooms, study areas and all that, right? And the quality management system to ensure that the effective delivery of the teaching program takes place. The structure of the program for engineering, according to the 2013 accreditation manual, this will be under revision. There may be certain changes in the near future, but basically it is the first category, mathematics, basic sciences and computing, 18 credits, engineering sciences and engineering design, 72 credits, and the complementary studies, 18 credits, right? So this adds to 108 credits, but the SLQF requirement is 120 credits for SLQF level 6 degree. The requirement of mapping, because we assess modules, but finally we want to achieve the program outcomes. So the mapping of the program outcomes to mapping of module outcomes to program outcomes must be shown to the accreditation body, so that we have assessed all these modules and that satisfies the program outcomes at the end. The future of technology education is to manage the introduction of new technology graduates to the industry. This is a new category of graduates, And we know that always a new category, when a new thing is there, the industry also do not, favorably react because we have the engineering hierarchy for a long period of time. It is difficult to break some of these conceptual barriers, and that is something that is challenging. Then higher performance and commitment to work excellence of graduates are paramount, because when the students go to the industry and prove that they are worthy and they can positively contribute to the growth of the industry, then the name is created. Then the consolidation of existing degree programs and curriculum reviews, because after now the first cycle is complete, the first graduates are out, now the faculties have to look at and revise the degree programs and align them to the industry requirements. Then the diversification of specializations to cater emerging labor market needs, and then the offer of postgraduate programs and applied research work in the future, because from the undergraduate level of education in these technology faculties must graduate to the postgraduate levels of teaching. Thank you very much.
Yeah.
Thank you.
Thank you, Dr. Piyasiri. Yeah. Please. So, we would like to thank Dr. Piyasiri again for excellent presentation. Taking the message that, okay, basically vocationalizing the education, the more opportunities for students in the A-level stream doing the art stream, and giving them an opportunity, know-how and skill to get them into the technology stream and be part of the capacity in the nation building and also creating employment. Also highlighted the benchmarking attributes with reference to international accreditation systems, and also future of the technology stream in terms of their employability and contribution potential, and also the attributes of the students and their way forward into further learning. So I think gives in a nutshell the key elements of the presentation of Dr. Piyasiri. We will have the Q&A session at the end of all 4 presentations, and then we would move to the second presentation of this session. It is my pleasant duty to introduce the second speaker. Can I request Engineer Heminda Jayaweera on podium? Yeah, and you can get the presentation ready while I do the introduction. He was appointed Chief Operating Officer at the Sri Lanka Institute of Nanotechnology, SLINTech, well known, a unique public funded private run science and technology facility. He is also Director of Capacity Building, SLICAN Trust at SLINTech. After over a decade at Dialog and Dialog Axiata, he co-founded the Internet of Things IoT-based company Effective Solutions. Over the last 4 years, he has co-founded Jendo Innovations, a medtech startup that uses software algorithm to assess patients' cardiovascular health based only on their pulse or no blood samples required. And with that brief introduction about, I'm sure that there is a lot more things to tell about Engineer Heminda Jayaweera. May I cordially invite to start your presentation, and we will, as usual, indicate 5 minutes ahead of the normal time. Over to you. Thank you.
Thank you, Professor Attalage, Chair of the session, and the other panelists, Dr. Piyasiri and the rest of the panelists, and all the dignitaries here. So I'm going to talk about, my presentation is a bit different, very few words, but I talks about not the technology aspect of innovation, it's more what really feels. So innovation mindset, this is something that a lot of people talks about nowadays. What really makes, what brings the innovation out of a person, and also what brings the innovation from a place like university, like KDU, or even a city, or even a country. So that's the area that I want to talk about. You know the story, right? A lot of people think ideas are very important, but in my context of innovation, ideas are not so important. What comes after idea is what is really important when it comes to innovation. Because idea is just a dot in your time, but innovation is a long process. And where a lot of countries, a lot of people, a lot of institutions fail in innovation is that they forget that there is a long process for innovation. You know the story of this cartoon, right? Every time what happens is the coyote or the fox tries to capture this bird who can't fly, right? But what happens is that a lot of people think what he makes, all these gadgets, they are innovations. Actually, it's not innovations, because all the time what he tries is, he never achieved the end objective of what he tries to do. He never catches. I mean, if you know the story, he never achieved the end objective. So for innovation to call an innovation, there are three things to be successful or achieved. One is it has to be something new. Then the end objective has to be achieved. Third one, there should be at least one user of what you have developed. It could be patented all over the world, right? But if there is no user, there is no innovation. That's a simple definition. It has to be used by someone. So just to give you very high level, don't believe what I say, but believe what Reid Hoffman says, one of the super angels in the Silicon Valley. He created the LinkedIn, so famous tech company. Innovations come from long-term thinking and iterative execution. So don't think that doing innovations are exciting things to do. See the word? Iterative. So you have to do the same thing again and again. I remember Thomas Alva Edison, when he built the incandescent bulb, not these types, right? He had to do 800 times until he find the right filament for it. So doing innovations are not exciting things to do. Remember that. If you want to see exciting things to happen, innovations is not your topic. Because you have to do the same thing again and again. Excitement comes at the end of the tunnel, right? Remember that. So if you don't have that courage, doing it, holding it for a long period of time until you reach the end goal, I think if you can't do that, innovations is not for you. So remember that. So you have to build that understanding. So when it comes to innovations, innovations are not just incremental innovations. I think you have heard about these words like disruptive innovations or disruption word. A lot of people don't know the real meaning of disruption. What is the meaning of disruption? The real meaning? The real meaning of disruption is that something that was the predecessor product has to go obsolete. So when a disruptive innovation is done, the predecessor product go obsolete. That's the only definition. So if that doesn't happen, you don't use the word disruption. So disruptive innovations, what they say is, this is coming from famous professor from Harvard University. He says this, if you don't do disruptive innovations right now, you can't survive in the current market. So that's what happened to the companies like Nokia, then the famous story of Kodak, right? So if you want to survive, you have to do disruptive innovations. Make sure that at least one of your innovations kills the current product. So all these products, if you look at the diskette, this is actually Walkman, all got killed because of these disruptive innovations. Pen drive, this is actually, the picture is wrong, but it is actually the iPod, not the iPhone, right? So read about these stories. These are all disruptive innovations. And also this picture, what is that? The famous car, one of the oldest disruptive innovations, Ford Model T. It actually killed what? The horse carriage, right? Not the car, because that was not the first car. There were a lot of other cars, but the cars were very expensive before that. And then what happened was Ford Model T brought in the so-called second generation of cars, where you have the chain manufacturing process. That's what he innovated, and the cars became a mass production, and cars became affordable for masses. So that's what he did. So when it comes to innovations, we talk about a lot of things like social innovation is a buzzword right now. So I think something that you have to understand. Again, innovation is about something doing new. There should be a user. But social innovation means you are doing a social good in the same process. It doesn't mean it's a CSR or doing something free. Even if you do a social innovation, you can make money. You can make profit out of it. But that profit has to go back into the cause. That's the only differentiation. But still, social innovation is something that you can make money out of. So there are a lot of examples. I won't go into details, but we can even discuss this during the Q&A. So now, the most important thing. Why innovations is important, that you know. Without innovations, you can't grow an organization. But how do you improve innovations? What are the simplest things that you can do to improve innovations? So there's this term widely used called idea collision. So in simple terms, idea collision means you have to share ideas. So what they say is, if you want to improve innovations, you have to start sharing ideas among different skilled people. It's not about 3 software engineers talked about software engineering among themselves. It doesn't create innovations. But if a software engineer discusses his idea with an artist and a business manager, then comes the innovation. So this idea collision is the single most important thing when it comes to promote innovation. So remember that. It's not about just sharing the ideas, but sharing that idea among different set of people who have who comes with different skill set. And there's no money that you need to earn. It's so simple. But if you can promote that in the organization, university, wherever, innovations will come out. So I'll skip this. So very simple things. So a lot of people talks about innovation is something that comes out as a tangible product. No, innovations can be even developing a thought process. Right? If you can develop a thought process, and if you can pass it to a lot of people, and if a lot of people start believing that, that's again an innovation. One of the best examples is all these products are free products, free to market. Nobody has to pay for these products, but everybody is using it. So this is a concept itself. Started very recently, maybe. Recently means maybe 20, 30 years ago. So that concept itself is an innovation. So coming back to Sri Lanka now, I talked about innovations, try to understand what is innovation, what it makes, and what's the status of Sri Lankan innovations. Now I'm just bringing this, actually it's a part of Harvard University research done about 6-7 years ago in 2015, I think. So this graph shows, on the y-axis it's the percentage of exports. On the x-axis from 1965 to 2015, how the different products developed. For example, earlier it was all yellow color ones are all tea, simple products like tea, cocoa, all plantation related. Then the green color one, which was started in 1978 after free market economy, that is the apparel industry, and it came to a peak in 2000, say year 2000, but now it's going back in downward spiral. So, but this is typical technology S-curve or industry S-curve. But the problem that we see in Sri Lanka is that usually in a lot of other countries we'll see when an S-curve goes in a downward spiral, another S-curve comes out. We can't see that S-curve in Sri Lanka. But if you go to some other countries, I'll show you, for example, Thailand, and even some of the countries, even Vietnam, we can see a different S-curve comes and takes off. And we don't see that in Sri Lankan context. So that's where we see there's lack of innovations coming out of Sri Lanka. So we see that IT industry is the next S-curve, but well, if you compare it with the apparel industry, still a long way to go. Apparel industry is about 5 to 6 billion, and IT is still about 1.5 billion. So long way to catch up. So again, some very important facts. There's the different organizations comes up with these facts in different ways. So one of the things is the product complexity index. it talks about high-tech products. And the percentage of Sri Lanka's products that go out of Sri Lanka under high complexity products is about 2%, actually it's less than 2%, right? But if you look at some of the countries like Vietnam, Thailand, now they have gone past Sri Lanka. So for example, you selling tea as it is versus extracting something out of tea and selling a pharmaceutical, right? So the cost of production may be high, but then the margins are really high. So Sri Lanka being a country that it talks about higher standard tea, but then what value additions we have achieved in the last 50 to 60 years? Not much. So that's what it shows. And the sad part is, compared to 1970s to now, this product complexity index in Sri Lanka has not changed much. It's still, it was 1%, around 1% in 1970s, and even now, it's actually less than 2%. So there's not much of a difference. But compared to Sri Lanka, a lot of other countries, Vietnam to Thailand, they have gone past really well in the last 30 to 40 years. If you take a country like South Korea, right now stands at 42 to 50% range when it comes to product complexity index of products that goes out of that country as export. So most of the products are high complex products. So high complex products are usually electronics, pharmaceuticals, biotech, nanotech, car manufacturing, shipbuilding, all these things, where a lot of high technology is involved. So there are methods how we can take a country forward. There are different benchmarks. I don't think any of the benchmarks that we should follow as a country, but these are benchmarks we can use. Maybe we can use a mix. For example, South Korea, how they developed in the last 40 to 50 years was, they supported, the government supported the big industries. For example, if you look at Samsung in 1960s, it was a very well-known brand in South Korea, but nobody knew about that brand outside South Korea. It was just a department store. But then the government of South Korea, what they did was they gave funding to leapfrog their technology. What is leapfrog? I talked about this technology S-curve. If we jump 2 technology S-curves, that is known as leapfrogging. So being a department store selling electronics, they moved into manufacturing electronics. So that's what they did. That was the leapfrogging part. And for that, the government of South Korea supported them. And the history, you know, Samsung became a chaebol, one of the chaebols. Today, the best consumer electronics company in the world, right? Within a 30 to 40 years period, passing a lot of other companies, even the companies like Sony, a lot of Japanese companies as well. That's the one model. Government supporting the big entrepreneurs and the big companies. Then the second model is the Israel model, where government started supporting the small timers, small startups, individuals, innovators, and the universities. So that's what happened. I think if you read the story of Startup Nation, it talks about 3 things. One is they supported the universities to promote innovations and entrepreneurship, number 1. Number 2, they created the venture capital industry in Israel, which is not available in Sri Lanka, for your information. We don't have VCs in the country. But they promoted, Israel government, they promoted venture capital industry in Israel. And third one is the government promoted these entrepreneurs to sell their product outside Israel. Because Israel is a very small country, about 1 million population, or maybe, about 7 million population, less than Sri Lanka. But that market is not enough for high-tech products that they brought in. So what they did was the government seek markets outside Israel, especially US market and European market. So those are the 3 things that Israel did, and Israel became a startup nation. Today, with 7 million population, they created 6 unicorns in the last maybe 10 to 15 years time. So again, little bit more details about the product complexity. This is Sri Lanka, how product complexity shows. This data is available, I think these 2020 figures. Go to this site, the growth lab of Harvard University. It's all data is available. The creator behind this is Professor Hausman. I think he came to Sri Lanka a couple of times as well. So all these blue color ones are actually high complex products, and the rest of the things are, even ICT goes as not so high complex unless it is using maybe AI or something really tech. So just making a website or something like that doesn't come as high tech. But if you look at High-tech percentage is very low, all the blue color. And if you go to a country like Israel, you can see a lot more blue spaces. This is what they export. Again, they have a bigger component called ICT, but then it's not too high complex, but it's also in the middle level. But then if you go to a country like South Korea, you can see the difference. It's majority, actually more than 50% or close to 50%, it's high-tech. So this is what makes a country a developed country compared to a developing country. So this is my last slide. I think this is where Sri Lanka should focus. The word product design engineering. I think I want to explain this a little bit more. So if you go to, say, universities, right? Universities do, I mean, even in the conference like this, we do a lot of publications, which is good. But these are more basic research. And the dollar value of what comes out of it is generally low, right? I mean, if you look at this particular conference, how much you spent and how much you earn out of that by selling this product, it will be very low. But that's okay. So that's the model. That's the model for basic research. But if you move to second tier, that is the applied research. I think if you look at the Sri Lanka, a lot of organizations like SlimTech comes under this. Applied research, where they produce something and come up with a patent or a IP, and they try to sell that. That has little bit more money than the kind of the money created in the basic research. But here, again, I don't think you can cover the cost of applied research by selling the patents. So that's what the eternal issue of organization like SlimTech, and it's not only Sri Lanka, a lot of other organizations, they face the same thing because they have to continuously, somebody has to pump money. Third one is the companies who buy these patents from these companies. These are actually B2B companies. Like example in Sri Lanka, a lot of IT companies in Sri Lanka coming under third category. They develop a product for another company. So example, Virtusa. Virtusa develop products for another company in outside Sri Lanka. They make a lot of money. A lot of component manufacturers, say China, I mean, if you take whatever the phone that you have, whether it's a Samsung or an iPhone, most of these phones are actually maybe built in China. It's maybe in the same factory. So these are called component manufacturing companies. If you know the name Foxconn. So Foxconn develop mobile phones for Samsung and also Apple as well, right? So these are component manufacturing companies, and they usually buy patents, develop patents from various companies like Applied Research, and they sell the products to the bigger companies like Apple to Samsung. So these are the companies that Sri Lanka should focus. We call it the product design engineering company. So difference between Foxconn and Apple and Samsung. So Apple and Samsung own the exact product design concept. For example, what Apple does is Apple develop everything, electronics to software to all the development, and they get it developed at the Foxconn in China, which is a third tier company. But the real money, the real value of the company is actually in the fourth tier. So I think if you look at all the companies that you talk about, Google to Apple to Samsung, all these companies are tier 4 products. We call it product design company. So that's where it's not only electronics, even if you take pharmaceuticals, biotech, say a company who produces medicine comes under this tier 4. So this is where the real money is. I think as a country, if we want to get into the real developed country status, this is where people should work. We should focus on end customer products. So my message to even to IT industry in Sri Lanka is that we should, it's okay doing component manufacturing or servicing, but we should move on to product design engineering. So that's where the real money is. So my time is up, and thank you very much. Thank you.
Yeah, thank you, Heminda, for placing a very clear message. And in the presentation, Heminda indicated the anatomy of the innovation process and really indicated what is called an innovation. At least there should be one user, right? So you can make a patent application, you can have license, but if there are no users, well, that may not be called as an innovation as well. And also very clearly indicated the term disruptiveness and the idea collision. And of course, finally, the message was a very important message, how to end up with a high value addition becoming a part of the process of product design engineering, rather than limiting ourselves as knowledge developing our entities as doing only basic research, where the value that brings is not that much in this timeline, but the immediate term probably. It might be in long term, but then the dynamics are quite different. So it's a very clear message. Thank you. I'm sure there will be a number of questions for both Dr. Piyasiri and Heminda at the end of the Q&A session. Let us now move to the third presentation. The third presentation would be an online presentation, and I will introduce the presenter. I am pleased to introduce Professor Bonaventura Hadikusumo. Professor Hadikusumo received his bachelor's degree in civil engineering from Università Diponegoro, master's degree in construction management from Asian Institute of Technology, and PhD from the University of Hong Kong. Dr. Hadikusumo joined AIT as an assistant professor in the School of Engineering and Technology, SET, and was promoted to the rank of associate professor in April 2009. Currently full professor in construction management. His research area is in project management, construction safety management, information technology and digital transformation in construction and simulation in construction project management. The title of the presentation would be made by Professor Hadikusumo, and we hope that we are connected with Professor Hadikusumo. Can you
very clear.
endorse that? Yes. Can you hear us?
Yes,
Prof.
I can hear.
So very warm welcome once again to this session, the plenary session in the technology
Thank you very
stream.
much. Okay, so I am presenting from Thailand. I hope you can hear me clearly. So can I share my screen now?
Yes, please. Yeah, thank you. We can see you.
Okay.
Hope you can hear us. You have 25 minutes.
Yes.
We will indicate,
Thank you very much.
provide the signal
Okay.
in 5 minutes before the time limit.
Okay, so
Yep. Please.
thank you very much for the organizer for inviting me to present my research about visualization technology for construction project. As now every industry is going to the 4.0, industry 4.0. So construction also, our trend is also going into this direction. And one of the important component is, of course, the digital construction, which also include visualization technology. Okay, so first I want to introduce you about AIT. Okay, AIT is Asian Institute of Technology. We are located in Thailand, and we also have a lot of students from Sri Lanka. Okay, this is myself. I think the organizer, the moderator has introduced me briefly. So I'm a professor in the construction project management. I have been working in AIT since the year 2000. Okay, so this will be the content of my presentation. So I will discuss the 4 items. Okay, start with visualization technology, virtual reality, augmented reality, and BIM. Okay, so visualization in construction. So I think our construction industry, we started with using the drawing, paper drawing. We make the drawing in the 2D design. So there are so many challenges with this 2D drawing. Number one, it's very difficult to be executed, okay, because the designer may draw in the 2D, the contractor have to interpret, and the interpretation may be different, and also there are design drawing which are produced by different discipline, architect, structural engineer, mechanical, electrical, and sometimes the conflict in the design happen. So then, okay, because of the fast growing technology development in the computer technology, so we in the construction also gain some benefit. We can apply this computer technology to visualize our construction project. Okay, so this is in the year 1980, 1920, we started with 2D drawing. I think everybody at that time used AutoCAD. Okay, AutoCAD was very famous. Okay, but again, this 2D drawing, the line does not represent any object. So the line, you see the line of the drawing, in the drawing, the wall, door, window, roof, but they are only line. There is no information embedded in the object. So then we go to the 3D modeling. Okay, so 3D modeling was popular in the year 2000. So at that time, okay, so the designer, they make the 2D drawings, and then after that, we'll hire the 3D modeler to model the 2D drawing into 3D computer object. Then we can see whether there is any incomplete design. Then we can rectify the problem before the construction start. So at that time there are many software that we can use. Okay, the famous is the Bentley MicroStation. Okay, so these are the example of the 3D object. Okay, 3D model. Okay, so now we can see much better than 2D drawing. We can visualize the object. Then the next development will be 3D model simulation. So 3D model only, okay, is not enough. Okay, we want to simulate, give more attribute in the 3D model. So what kind of simulation? Example, we can simulate the scheduling. We can simulate the safety aspect. Okay. Okay, so this example of the 3D drawing. And okay, now I will show you one of the 3D simulation that we developed for the Hong Kong Housing Authority. Okay, so please, I will share another video. Please wait. Let me open my file. Okay. Okay, I hope you can see. So, okay, so I did not turn on the sound because I need to explain to you. What is this simulation. So this is example of the 3D construction process simulation. As you know that in Hong Kong, the construction, the duration is very tight. Okay, so, and then the site area is very small. So we have to simulate this construction so that we can get the best process, okay, before we do the construction. So as you can see, this is the example of the 3D simulation process. And when we conducted this research, was in the year 2001. The computer processing was only Pentium 2. Okay. Now your computer laptop at least is I7, I5, which is maybe 25 or 30 times faster than what we did in the year 2000. So at that time, the challenge was how to present the simulation smoothly, because we don't have enough computing speed capacity. Okay, so this is example of the 3D simulation process. Okay, now I continue with my presentation. Okay, please wait. Please wait. Okay, now I continue with my presentation. Okay, so what you see just now is the 3D construction simulation process. Of course, we see the benefit. Okay, the benefit, we can view and analyze the digital 3D model. We can plan the construction sequence so that we can achieve the most optimum sequence, and we can also visualize the movement of the equipment and other site analysis such as safety. Then in the year 2010, okay, so the BIM becoming important, starting. So a lot of projects start using BIM in the year 2010. Of course, the idea of BIM has been established since maybe beginning of 2000, but the real application becoming popular in the year 2010. So this is example of the building information modeling. So in BIM, every construction component has the information. So when you see the wall, we have the information about wall, such as the thickness, the type of the wall, and then also the height of the wall. When we see the visual 3D of the pile foundation, there is also information what is this pile foundation characteristic. And BIM can be used in the design phase and construction phase. So one of the reasons why we use BIM in the design phase is for the clash detection. So this is example of the clash detection. So we can visualize and we can conduct analysis how many clash detection occur in our model. Then this will make the job of the designer easier, because the software can calculate the number of the clash object. Then BIM can also be used in the construction phase. Okay, example, BIM can be used in the detailing. Okay, because in the construction phase, the contractor need to make detailing of the steel structure. So this BIM can also be applied. And okay, BIM can also be used for the 4D CAD simulation. So 4D simulation means 3D object plus schedule. So we can integrate 3D object, 3D model with scheduling. So what is the benefit? The benefit, we can see or we can visualize what are the construction progress at a certain date. Okay, so that will become very useful for our planning. Then BIM, of course, we can also develop our specific applications. Okay, it depends on the company need. We can develop BIM specific for example like safety, risk visualization, cost control. Okay, so we can always add something on top of the BIM. Okay, so now I will show you one of our research BIM for safety risk visualization. So this one of the researchers is from Sri Lanka, okay, my student, Mr. Sanjit, who is now working in the team consulting Thailand. Okay, so this is the safety visualization framework. I will go very fast because this one is a bit technical. So we use Revit architecture. We use 3D Studio Max to make the 3D model. And then we use Microsoft Project to simulate the 4D, okay, 4D, the scheduling aspect. Then we develop our specific safety application on top of BIM. So the safety application can be used for job hazard analysis and also to represent the safety profile during the construction phase. And of course, we have to do the coding. The coding include using Navisworks, Microsoft Visual Studio, okay, and then we can simulate the construction in terms of schedule plus safety risk profile. Later, I will show you the simulation. Okay, I will not explain, it's too technical, okay? So I will just go directly to the example. So I will go directly to the example. Okay, so if you are involved in the risk management, then I think you are familiar with this risk assessment. So this risk assessment is done manually, and then after that we try to integrate this one with BIM 4D model. Okay, so I will give example now. Okay, this one is too technical. Okay, I don't want to explain too detailed. It's very technical. Okay, so basically, okay, we want to simulate the risk level. So when we see the risk level is high during the particular day, then we know we have to deploy more safety supervisor, or we have to work is high. So this will be useful for the safety engineer, because safety engineer have to control the risk level. Okay, now I will demonstrate example of our BIM for safety. Okay, please wait, I will open the video. Okay. Okay, this is the video. Okay, I will go directly to the system demonstration. So, I will show you how this application is used in the real project. Okay, so the project is the MRT, okay, BTS Green Line is the mass rapid transportation project. A lot of risk, safety risk happen. That's why we have to control this risk. So okay, this is example. Okay, there is no sound because I need to explain. Okay, so this is the example. On the left screen, you will see the 3D object. On the right screen, you will see the risk profile. So this is an example of the 3D simulation. Now these are the constructing the pillar for the I think this one maybe the foundation. Sorry, the foundation of the structure. Okay. So you can see the risk profile on the right side is moving up and down, depend on what activity we have. So when you see the risk level going up in a particular date, then we have to manage the site more carefully. Okay, so this is the example of the BTS Skytrain construction. Okay, so the idea is, okay, we have the construction project and we need to visualize the risk. So this visualization will help the safety engineer to better manage the safety on the site. Okay, so I think you may have some idea. Okay, I go back to my PowerPoint. Okay, then, okay, this one I skip. Okay, this one is the detail how to do it. Okay, so this is the video that I just showed. So the video is the BTS MRT project. We try to visualize the risk level. Okay, and another technology is the virtual reality in construction. I think you may have the idea of the virtual reality. So the first video that I show you is also a virtual reality project. So the idea is we want to present the project in the computer 3D model, but we try as much as possible to visualize, looks like this is virtually real, okay? Because we want the planner to be able, the engineer, the planner to be able to see what will be the construction look like. Of course, now with the better computing speed, we can have a better quality of virtual reality representation or rendering. Okay, so it depends on the, of course, depend on the quality of the VR technology. Okay, the highest quality we can represent with very high quality image. Okay, so another technology is the augmented reality. So augmented reality, sometimes we call as the superimposed technology. So in this augmented reality, okay, we can see what will be the construction project. We can see the hidden construction element. Okay, we can use for the training, and we can also use for the maintenance procedure.
Professor Hadikusumo, you have 5 minutes more, just to note.
Yes, thank you very much. Almost finished. Okay, so this is the example of the how to use the augmented reality for the site construction. So when we bring our augmented reality gadget, okay, then we put it on the site, then we can visualize where will be the location of this project, okay? And this is example of the augmented reality for maintenance, okay? So underground maintenance, we need to know what are the facility below underground. So we can use this augmented reality to visualize what are the public utility under the ground. And this is augmented reality for the training, okay, operation. So using this augmented reality, we can guide the trainee to understand how to operate this equipment, okay? And also for maintenance, we can also use augmented reality. Okay, so in the IT, we also have this augmented reality research, okay, but I will skip more or less. Okay, so I finished my presentation. So the summary is, I think construction industry also, we will go into the construction 4.0, and then we will use the a lot of computer technology, because we also want to go into the direction of the digital construction. So, and one of the most powerful tool is the visualization. So I think this area will be used in the construction, and there will be a lot of opportunity to develop software, to develop tools to support this digital construction. Okay, so I finished my presentation. Thank you.
Thank you, Professor Hadikusumo, for bringing in a new dimension into this construction project area or the discipline by presenting a visualization technology, well, incorporating modeling and simulation, building integrated management system, risk assessment, and also finally with incorporation how augmented reality can add value into the construction project management and also from the design stage, I guess. I'm sure in the question and answer session, so be connected with us. There will be questions for you that we could direct, and we'll catch up with you in the question and answer session. Thank you once again.
Sure.
And
okay, thank you.
Yes, we come to the last presentation of this plenary session on the technology. That will be by Dr. Nutthachai Prongmanee. Dr. Nutthachai received his bachelor degree in civil engineering from Suranari University of Technology in Thailand, master degree in geotechnical engineering from Asian Institute of Technology, Thailand again, and PhD from Saga University, Japan. He worked as a research assistant at Suranari University of Technology and as geotechnical engineer in CIFCO Public Company Limited. He serves as an assistant professor, and he's also the head of Center of Testing and Research on Materials in Civil Engineering in the Department of Civil Engineering, Civil and Environmental Engineering, Faculty of Science and Engineering, Kasetsart University, Thailand. Dr. Prongmanee has been appointed as Secretary, Treasurer, and the newsletter editor under the Thai chapter members of International Geosynthetic Society. And this is the invitation for you to commence your presentation, Dr. Nutthachai. You have 25 minutes, and we will indicate to you 5 minutes ahead of your allocated time. Thank you. Over to you.
Okay.
You can share the
screen.
Thank you
very much.
Thank you.
Okay. Thank you very much to give me the opportunity to present this one. I was invited by Dr. Selesh. Actually, Dr. Selesh, he is my senior at Saga University. So, okay, I share my slide presentation. Okay, shall we start? Okay, today I will give you the presentation on the topic of the introduction of the new approach for the cement content determination of the pavement recycling for laboratory inspection. So in this presentation, I make it very simple to you guys can very easy to understand, because maybe you from different background. So let's start. So the highlight of this presentation, so we develop the new approach to predict the cement contents. So by using only the 2 laboratory trials. Generally, in past, the lab supervisor, they need to conduct the test specimen at least 5 trials. So by using the laboratory trials, you can save the amount of materials used. Also, you can save time and the cost for the construction project. So let's introduce what is the flexible pavement. So flexible pavements, so actually the pavement stuck of the asphaltic concrete layer, this one surface cost. The next layer is the base cost, and subsequently layer is the sub-base cost. Then is the existing ground. So this kind of the pavement structure is is quite popular in Thailand because this one way, when you drive the car, it feels very smooth. However, this kind of the pavement structure is really fast to damage. As you can see, the figure below, this show the damage pavement. As you can see, many holes appear on the pavement surface. So after using for some time. So in case if the slightly damaged, so the contractor just dig up the damaged part and then overlay it by using the asphaltic concrete. This one is very simple. But in case if your pavement have the very highly damaged level, so it should be repaired by using the pavement recycling method. This one is very popular in Thailand now. So one is the pavement recycling. Then the construction need to milling up the old pavement and then mixing with the cement and water. Then they compact to create the new base cost layer. So in case of the pavement structure is damaged. So this slide shows the sequence of the machine used in the pavement recycling. It consists of the feeder. So it consists of two components, is the cement and water. And then the milling and the mixture mechanic. Then grader and the compactor. So the sequence is the water and the cement was feeding to the milling. Then the milling one is dig up the old pavement and mixing with the cement and water. And then they need to make the load is leveling, design level. So it's using the grader to adjust the level of the load. Then it's compact to make it become harder. So before perform the pavement recycling, the two things it need to know is one is the water content and another one is the cement content. So these two things should be conduct in the laboratory. As you know, the water content is very easy. You just conduct the compaction test and then you get the optimum water content from the laboratory. In case of the cement content, so I introduced the conventional method for determine the cement content. So firstly, the lab supervisor need to determine the optimum water content by conducting the compaction test. Then we need to assume the cement content by varying from the 2 to 8% and using at least 5 samples. After that, they create the test specimen by compact the mixing soil with the water at the optimum water content and the cement content, and then create the test specimen. After that, they conduct the unconfined compression test. In Thailand, the standard, they need to keep the curing time for at least 7 days. After that, they plot the relationship between the ultimate compressive strength with the cement content. As you can see here, this figure, where the x-axis is the cement content in percent versus the unconfined compressive strength. It should be the ultimate one. So at least the 5 points need to plot, then you draw the linear line. After that, determine the desired cement contents by using the minimum requirement following each the standard. For example, in Thailand, for the base cost cement, they require the minimum requirement about 24.5 kilogram per square centimeter. So after 24.5, you can obtain the desired cement content here, 5.5. But by using the following method, I will present in the next slide. So you can use only 2 laboratory trials to get this desired cement content. I think is useful for you at least. So according to the problem above, so they need many test specimens, at least 5. So we create the laboratory to conduct the test and then to produce the method for determine the cement content. So we use 3 different type of the soil. So the first one is the cut rock mixed reclaimed pavement asphalt, we call CR. And another soil we use the lateritic soil, so we call LS. And the last one we use the mixture, the soil between the number 1 and number 2 soil. Then we conduct the grain site distribution analysis. So as you can see in the figure, all 3 soils inside the minimum requirements based on the Department of the Highway Standard, Thailand. Here, so it means that so the T soils can be used as the construction material for the pavement structure. After that, we conduct the Attalage limit test for T aggregates. So as you can see here, the LS consists the highest, the liquid limit and plastic limit. So this is the plastic consistency. So because the lateritic soil consists the 5 particle, so the highest 5 particle. So based on the USCS standard, it can be classified as the silty sand. So for the CRL, so the liquid limit is about 20% and plastic limit about 5%. So it's classified to be the SPSM. So the last one is CR. So it cannot conduct the Attalage limit because this soil is the non-plastic one. So based on the USCS, it's classified as the SW. So the purpose why I use this T soil, so I want to vary the T soil with the different plastic consistency. If you can see here, the CR is no non-plastic, and LS is the highest one. So with the different plastic consistency, I will use to create the predict equation. So this slide shows the compaction characteristic of the T soil. So we use the modified Proctor energy to conduct the test. As you can see here, with the water content increase, so the dry density of the soil increase up to the highest one and then reduce. So this the common compaction characteristic of the soil. So based on the Attalage limit test here, so I can calculate this parameter called the plastic city index. Is the can determine from the liquid limit the minus plastic limit, this one. So the test result show in here, the table here. So where the LS have the plastic city index about 20, CRL have the plastic city index about 16%, and the CR, as you know in the previous slide, showed this is the non-plastic one. So up to here, our hypothesis show that we have the hypothesis that the PI control the compaction characteristic of the T soil. As you can see here, when you increasing the PI, so what we can see, so the optimum water content of the soil increase and corresponding to the reducing of the maximum dry density. So the test results show that we can conclude that the plastic city index is the important parameter to control the compaction characteristic of the T soil. So we use this PI as the key parameter. So after that, after we know the optimum water content, so we create the test specimen to conduct the unconfined compression test. So for each soil, we conduct 50 samples. So we using the 4-inch mole for the standard Proctor, but we use the modified compaction energy to create the test specimen for each soil. And then we curing for 7 days, and then we conduct the unconfined compressive strength test using the CBR testing apparatus to consider the ultimate strength one. So after we get the QU value, so we try to plot the relationship between the water to cement ratio to the ultimate compressive strength. As you can see, this the test result. So within 50 test specimen for each soil. So the x-axis is the water to cement ratio, and the y-axis is the ultimate compressive strength of the T soil. As you can see, so by increasing the water to cement ratio, the strength of the material reduces. And to fitting this set of the data, so we use the power function to fit this, and with the R square, you can see is the acceptable range from the 0.75 to 0.89. It's quite good fitting. So with the power function, the QU is equal to A, where A is the y-intercept one, and B constant is the slope of the function. So we get the QU is equal to A multiplied water to cement ratio powered by the B, constant B. So this table summarizes the constant A and B we get from this set of the test result. As you can see here, for the constant A, the value of the constant A for the T soil is almost the same. So we assume that this one is the constant, and we use the average one for the representative of this constant A value. So the average one is about 3,554 kPa. This one is very important. So if you use this value, it should be in the kPa, because we fitting from the kPa unit. So for constant B, so the test result is different from the T soil, and we have the hypothesis that it should be related to the PI value. And this slide show the relationship between B constant and plasticity index, as we discussed before, because we have the hypothesis that the PI control the compaction characteristic of the T soil, and then we create the function. As you can see here, okay, I think it's the acceptable. And why don't we use the another ligation analysis? Because I want to simplify what the developed equation we want to be developed. So I use the linear one. It's very simple, and you can see here is okay, acceptable. And so what we get the B constant is equal to minus 2.5 times the plasticity index minus 0.5. After we know how much B constant and A constant, so I substitute to this equation. So I get the predict equation for our confined compressive strength QU. So this equation where QU is equal to the A constant, or this multiply the water to cement ratio the power by the B function here, and the length of the water cement ratio we study should be in this length, 1.5 to 4.5. With this, so very simple. So we use only PI and the water to cement ratio. We can get the QU. After that, we verify the proposed equation by using the data from the literature. So the two regions we use, Thailand and Nigeria. So the proposed equation show is good, fitting with the R square about 0.9 from the test result set from Thailand, and R square 0.86 from Nigeria. So up to here, it can be concluded that the proposed equation can be used generally. So then we develop the method to determine the cement content by substitute the minimum requirement value from the standard. So up to here, if you can substitute the value from the difference, the standard, anywhere from the world, so you can get the proposed equation to finding the cement content by substitute here and rearrange. You can get the CP. So then we verify the proposed cement content here, where the X is the predict one and Y is the actual one. As you can see here, so scatter and accuracy one is very few. So up to here, we think, okay, only one specimen test is not enough. So by using our proposed equation cannot be get exactly the cement content. So we another develop the way to get the good one. So we use the upper bound and lower bound. So if one cannot be get the C exactly, so we use the two specimen. So here by plus 2% and minus 2%. So then we can develop the proposed procedure here. Firstly, we determine the optimum water content and the plasticity index. Then we calculate the CP by using the two parameters we get from laboratory. And then we use the upper bound and the lower bound one at the cement content. Then we create the test specimen and determine the ultimate compressive strength from the laboratory. Then we plot the relationship between the two cement content we get and QU we get, and draw the linear line. Then we substitute the minimum requirement to here, draw here, and then we get the desired C value. So this slide shows the verification of the calculate and measure one in the real case project. As you can see, the white one is the predict one, and the black color solid line is the actual one. So you can see here, we can get almost the same cement content by using only two laboratory trials. So this they use 4. So conclusion. So PI and water cement ratio is the main parameter control the QU value, and the proposed equation of the QU we consider only W over C and the PI value, very simple. And suggest procedure for cement content determination is very useful. So because we can save the sample number, we reduce from 5, we can conduct only 2 samples, and then time and as well as the overall cost for construction. So thank you very much. We have some technical problems, so maybe over time. Okay, thank you.
Yeah. Thank you, Dr. Nutthachai, for sticking to the time limit and also taking us through a presentation where you enumerated a new method of determining the cement content for pavements and make comparison and indicated what advantages is present compared to the conventional method of estimating the cement content. Please stay connected. We will be now going into the question and answer session. If there are questions, I'm sure from the audience, we will direct it to you, and so we expecting you to be connected. So with this presentation of Dr. Nutthachai, we come to the end of the lineup of presentations, and now we will go to the question and answer session. Invite from the audience. We have two presenters here in the head table, and two presenters connected to us through internet. And well, we can request the questions from the audience first, and then we can also see whether there are questions through the chat box. Do we have a microphone to be circulated? Okay, well, I'm sure it's a full audience. There are definitely questions to the panel members. Who wants to go first? Yeah, yes.
Well, yes, I have a question from the back seat. So,
first, can you introduce
yes,
yourself so that this will be recorded?
Okay. So I am Udara Sachindra, a lecturer at Attalage Defense University. So my question goes to Engineer Heminda. So actually, thank you very much for a nice presentation and your informative session. So I think we have to accept that innovations may take some time to convert into a profitable stage. And I think even most of the young individuals who are in innovation side, so they are discouraging, like because of this. For an example, they might start with a new concept, and they start developing it, and they might discourage since it's not coming to profitable stage. So what is your advice for, let's say, for individuals, individual innovators, to get rid of that, and how to continue the path to make it a more successful, let's say, startup?
So innovation doesn't have to be profitable. So remember, but to complete innovation, what needs to happen is to take that product to the market. So at least there should be one user. But entrepreneurship, that's where the differentiation. So if you want to be an entrepreneurial venture, then it has to be profitable, or at least break even, otherwise you can't survive. So I think your question is more on the entrepreneurship side, sir.
My terminology is not correct. Yeah. Thank you.
So to become an entrepreneur, I think that's where you have to be very specific. So what you need to build is that you have to be long-term look at it. So for example, a lot of things that where a lot of entrepreneurs, the young entrepreneurs fail is that there are certain things that they have identified. About 50 to 60% of the reasons are nothing to do with the technology. If at all it is the technology, it's not on the right time. For example, if you look at some of the technologies that if you develop very early stage, maybe you are too early for that technology for people to really accept, right? For example, what happens to Google Glass? Right, in 2018, they closed the project. And now actually it's a B2B product only, for business to business product. Of course, it came up later. But they realized the technology is fantastic, but people are not ready to use it. So if you fail, it's not because of the technology, you are ahead of the time. But the rest of the reasons for you to fail, or maybe you take so much of time to get into profitable state, is because that's the soft skills of an entrepreneur, of a person, or that you don't ready to co-create or work as a team. Because entrepreneurship is not for someone who can build only as one person. For example, you may be really talented in certain area, technology, but there are a lot of areas that you need to develop. Even innovation is the same. Maybe you are the best person in mechanical engineering, but you can't become an innovator in mechanical engineering, because for that you need to have a lot of other areas that you need to cover, even other engineering fields. Maybe material science, maybe the science that is not directly related to maybe engineering, for example, the business side of it. maybe customer-centric knowledge, the legal side of it. So one person will not have all that data in one person. I mean, you can't be an expert in everything. So that's where the teamwork is required. So a lot of failures that you see is that you don't have the right team. And so the biggest reason that we have seen, if you look at not Sri Lanka but outside Sri Lanka, the technology is not at the right time, or the product that you are trying to put it in the market is not at the right time. Second reason is that you don't have the right team. So if you don't have the right team behind it, that fails. So it's, I think, where you have to be really focused on is to build that team.
Okay.
Thank you very much.
Yeah, thank you. Dr. Kogolagi, I think you.
For Engineering Technology, University of Vocational Technology. I saw many interesting presentations. I think our online presenters are connected, no?
Yeah.
Because
I believe, yeah.
I'm referring to Professor Hadikusumo.
Hadikusumo. Okay.
Yes, Hadikusumo. Very interesting to see, like using latest technology, especially digital technology like virtual reality and augmented reality.
Professor Hadikusumo, are you there, connected, Professor Hadikusumo? All right, yes, okay. There's a question for you. Yes.
Yes, first I put forward it to you and also our expert panel as well. Well, I'm not against latest technology and applying it. Of course, there are many advantages, as you have mentioned. But of course, my background is computer science and engineering, so I know how to code in and develop applications. But in this case, I use in developed applications like 3D simulators and so on. This is not against using latest technology to gain advantages, but do you see any kind of dangers as well when using these things? I'm put this in a different way. For example, now if we totally depend on these simulations, calculations, if something goes wrong with the program itself, the user doesn't know. So I think we are from older generation like Professor Attalage, Dr. Piyasiri and so on. We know the basics when we know. For example, our time, for example, mathematics. We can do certain calculations mentally. But when the new technology, like using calculators and so on, even when we go to shop, they cannot do even basic simple addition or so on. So when using this kind of latest applications, probably the new generation, they might not know the basics and totally depend on applications. So is there any danger or something like that? I would like to know.
Yeah. Professor Hadikusumo, I hope you got the question.
Okay, so
yep.
Yes, thank you very much. Of course, every new technology has advantage and disadvantage, I agree. Okay, so basically the simulation is trying to present in a better way, because the 2D drawing, we have to interpret the drawing, which sometimes take longer time, more difficult to interpret. So this 3D simulation will benefit in terms of better planning. So it doesn't mean that we will not teach the young engineer the basic project management function. They still have to learn this one, and on top of this one, to better accelerate in terms of the work planning, we provide another advanced technology. Yes, I agree that everything have advantage and disadvantage we have to analyze. Example, what happened if the data that we kept in the server crash or maybe attacked by virus? Then we have to be careful with this one. Okay, we may have to develop backup data. So that is my answer. Thank you.
Okay, thank you. Hope that clarifies your concern or issue. I don't know whether you need any other additional, but if I want to, give some, my thoughts. Okay, I also use this software extensively, but of course, first thing is that software, well, sometimes it's public domain, sometimes you have to pay and get. Most of the software, you might be a user. So first thing that you should know how to interpret the inputs to the software and then be able to relate. So that's the skill. It's not a basic user as such, because these have been developed by, codes have been written with experts who are knowledgeable in the subject, but the danger is that at the usage. So if you are able to identify what are your exact inputs and then be able to interpret the outputs. Also, it doesn't come like that. You need to have a verification process, and it has to go through the verification process. Your skill is developed based on verification process. So as a young user, you might not have that, but it will be under mentoring, and then you will have developed this. That's how I see it. And so, because it can do many things that simple hand calculation or thinking cannot do. It takes a lot of time, and you might miss certain things. But here it's challenging, but nonetheless, I believe it's advantageous. Right? Okay. Yes.
My question is, I'm Dean of the faculty, Dr. Premodasa. My question is for Dr. Piyasiri. So thank you very much for your speech, which is appropriate for a new faculty like ours. Now you talked about positioning the technologist among other professionals. So how, in your opinion, how prepared are the industries, local industries, to position a technologist, especially among other engineering professionals?
Right. Now, this engineering technology profession is new. Right? Now, the structure that we had so far is engineer and then the engineering diplomate. Right? And then they were handling it. And engineers are basically to solve the complex problems of design and innovation and all that, and they are the technology leaders there, right? But when it comes to application of that technology and the known areas of design, all that can be very well performed by these engineering technologies. That is what the West do, right? And then the engineering diplomates and engineering technicians, they play their roles. Now, at the moment, this slot is either served by the engineers or by the engineering technology, the engineering diplomates. That's how it had been in operation. But by bringing this new group of people who are, having the real graduate attributes identified by the industry, I think they will play the major role in implementing the new technologies, right? Implementing technology, especially in the small and medium industry sector. The large industry sector, generally you have engineers, right? Engineers, and they sometimes may play the engineering technologies role too there. But the small and medium engineering sector, industry sector, do not have that kind of technology, qualified personnel, and they have to come in. And these small and medium industries, the main barrier that they have for development is the applications of new technologies. They must bring in new technologies. Many of those places are run by the owners who does not know much about technology, but from the practices that they have learned, either from their parents or from various places in the industry, they apply and run. But we need to bring in the more systematic approach of engineering approach to these places. So I think this is where the largest impact that these graduates can make. Then in addition to that, there will be various other employment opportunities, right? Now when you look at engineers, where are they employed? Certain numbers are employed as engineers. Some in the banking sector, some in the ICT sector, right? And some in various other sectors. Okay. So engineering technology graduates will also may follow the same path. Some may work as engineering technologists and some may go in various areas. In a recent batch of customs officers, 150 custom officers recruited, 67 of them had been engineering graduates. Right? So similarly, it is wide open. It's wide open. So I'm sure the small and medium industry sector, which is the largest sector in the country, will be very much benefited by these technology graduates, and that will create a large, revolution in the industry in years to come.
Okay. And thank you very much for all the services you are doing to establish the technology sector and the education in Sri Lanka. And I have another question to Engineer Heminda. Thank you very much for thought-stimulating speech. And you talked about the importance of idea collision. Now, if you take a technology faculty, unlike any other existing faculties in a Sri Lankan university, consists of professionals from different backgrounds. It's a faculty with professionals from engineering and IT, and mathematics, biology. So this is, in my opinion, is a good place for idea collision. So in your opinion, what is the role of new technology faculties to promote innovation in the country?
Yeah, I think that's an ideal kind of model to promote innovation. As I said, innovations happens when there are different kind of people come together. So I think what you need to have is the model of education in the university. I mean, university education was defined as, it's not about lecturer speaking to students or students writing down the lecturer's notes and, go home and do an exam. So that's not university education. That's the tuition class model. So I think what you have to do is run the real university model with the technology students. For example, lectures can't be more than 25 minutes. Then after that, it has to be the group work within the classroom. So it's a 2-hour lecture. This is active learning that is used at Rice University and all these places where students don't sit like this. You sit in a round table, like in a Montessori class, and they discuss. What the lecturer gives only is the pointers. And after that, the students will discuss. They will have the mobile phones, they will have all the laptops, internet, everything. They study a bit more. Say, for example, if I'm talking about transistor, they will study about transistors. Students discuss each other, and then they come back and discuss that with the teacher or the lecturer. So then the lecturer guides, and maybe you can run the so-called kuppi within the class. So maybe a better student in that group, that the student can be a teacher to other students. So I think you run the entire thing within 2 hours. So that's the model which promote innovations. So if you can run the classes, lectures in that way, I think you will see a vast difference at technology faculty. Because there's a lot of people from different backgrounds come and discuss about things.
Thank you, Heminda. Yeah.
Yeah, I'm Ratnasiri. So I have a question to Dr. Piyasiri. This is actually I'm asking a very critical question from you regarding the technical education. In advanced level, mathematics subjects in the basket, no? Now we have achieved our object diverting art students to technology, but I feel that even the I think none of the technology degree program cannot be, it's difficult to teach without basic mathematics.
Yeah.
So once they come to here, we don't have, even in the state universities, they are teaching again chemistry, mathematics and physics with a short time period. The student cannot digest actually within that short period, and we cannot teach the subject without knowing the basic mathematics. My sincere request is there any possibility to take mathematics subject out of the basket in the A level, and at least to make it complementary or something like that without taking to the disco calculations? At least they must have S-pass, just knowing, even no need to pass the advanced level. Even student fail entirely, they have learned actually the subject. That is very, very much needed. So my request is that's the question number one. Question number two is, now once we establish the technology faculties in 2016 and 17, now one cohort is passed now. Now for the biosystem technology, actually now you have made the initiation and now streamlined the accreditation process. So what about the energy technology? Stream with the Sydney Accord, are you in the preparation for the accreditation?
Energy tech.
Engineering technology.
Engineering technology, yeah.
Engineering technology.
Yeah, yeah.
So my question number one and two.
Right. Now, in the basket, this subject called mathematics is not combined mathematics. There's another subject called, because there are 3 mathematics subjects in advanced level. One is advanced mathematics, then the next one is the combined mathematics, and the third one is what's called mathematics. It is not a higher level mathematics like combined mathematics. This is a more of general mathematics part, but it will take them above the GC O level mathematics level. So that is the subject included into this basket at a later stage. Earlier the basket had only 10 subjects, but now this mathematics has been brought in, and very few students take this subject, right? Because now when you look at this science for technology subject, which is compulsory for all the students, biosystems as well as engineering technology, that has mathematics, physics, chemistry, and bit of computing, and that area. So they learn mathematics to some extent, but it is understood that it is not very much sufficient when it comes to engineering technology education at the university level. So that is why most of the faculties have spent quite a good amount of time in the first and second semesters in giving that mathematics know-how. So I think the ISL new accreditation manual that they are formulating will also emphasize on the higher number of credits for mathematics and pure sciences, so that that first bar section of the curriculum, mathematics, pure sciences and computing area, that will have more number of credits. And similarly, these faculties also have taken various initiatives to teach mathematics, because during the orientation program also they teach certain sections of mathematics, as well as during the first and second semesters they have various innovative approaches. Now, say for instance, Rajarata University, they have recruited the recently retired professor of mathematics from Peradeniya University, and he has brought in a lot of innovative ways of teaching mathematics to the students, which has really worked. So I think that's the kind of approach that we have to take. And now the first cycle is complete, and because of that, we have to review the degree programs in all the universities. And with the new accreditation manual also coming from IESL, I think that is the right way of doing it. So we have to have a concerted approach as to how we do. But one thing we have to remember is they do not need mathematics as for engineering students, because engineering students go for highly analytical aspects of engineering, and here these students are more on the applications of technology and in engineering concepts rather than the new designs, right? So the differential equations, various analytical mathematics, they don't require. Right? Now, the second point you said about the accreditation matter, so far we had been using this 2013 accreditation manual, and these degree programs were designed and operated according to that. But now the ISL is looking at the accreditation manual, and there will be a revised version coming out very soon. And there was a bit of a issue on the recognition of these technology degree programs and all that. But now several discussions were held between the UGC and the Institution of Engineers, and we have a written proposal from Institution of Engineers to the UGC, which will be discussed next week at the standing committee. And I think there is a way out. The proposal given by IESL is acceptable, and so this will be further discussed and agreed upon. So with that, there will be this new revised version of accreditation manual will come. And so with that, the accreditation issue with the IESL will be solved in my view. So will that be sufficient for you?
Yeah, that's a good point, Dr. Piyasiri. I think still their website, IESL website, it says prerequisite for membership, even affiliate membership is A-level mathematics. It's indicated there. I don't know.
It had been changing. It had at one time when they put the recognition manual for Sydney Accord, that had technology stream, accepted as the pre-qualification to enter the university, right? So anyway, this matter is now, I'm sure this will be solved. Yeah.
Very good. Thank you.
Okay, thank you. I think we have come to the almost end of the session.
Yeah.
Using the privilege as chair, I will have two quick questions to my colleagues here on the head table. First to Dr. Piyasiri. Well, excellent. I mean, vocationalizing the education, we need to have the engineers, then the technologists, and the craft. That is the structure, and the pyramid is the structure. Yeah. Now, we are revitalizing our economy, looking for foreign exchange, etc. Now, with this technology stream, how do the planners see the future? Is that whether their know-how, the skills are to be used within the country and develop our the technological capacity, or use their knowledge and go out and work elsewhere and send foreign exchange? Well, how do our planners see? Is it a combination of these two, or leveraging one either?
Yeah.
Is there any potential answer for this?
Yeah. The planners will be the development of the industry within Sri Lanka. That is the primary. That's the primary. Because going and working elsewhere when we have excess manpower is a short term, way of earning money and all that. But what we really want is we need to have our industries develop, manpower develop, so that our industries will grow and our new entrepreneurs will come, and there will be a total economic and industrial development of the country. That is the first priority. But within that framework, the excess manpower at certain times, like what we have now, the economic situation and some of the economic activities have gone down, all that, in such situations they may go out and work. So that's the model that we are expecting. But at the same time, we will see, when you look at this labor market movement, our labor, say when we look at the construction sector, now when you look at construction craftsmen, and that is the largest shortage of manpower, and that is why many foreign workers were brought in to work in our Sri Lankan construction industry. So this kind of labor movement may take place in the future also. This is because the labor market is not local to a particular country now. The labor market is for the region, it's more expanded. So people look for opportunities elsewhere, depending on the wages and the income levels and all that. So people look that way. But the main purpose of the planners is to develop sufficient manpower within Sri Lanka for economic and industrial development of the country.
Okay, thank you, Dr. Piyasiri. I think that's the correct way forward. I hope that that will. A quick question to the last question to Heminda. Yeah, I mean, we know that Sri Lankans are our education, primary, secondary, and tertiary education good. I mean, well structured, robust, etc., well known. But we see that the things are not happening the way that we would like to. Coming to innovation, we know all the ingredients, right? But nothing is kick-starting to the level that we want. I mean, we would like to see countries like having companies in the Fortune 500. Few companies would be good enough to take the country to another level, even if you take Japan. Well, it's countable number. Of course, there are SMEs, but the leaders are really countable. What has gone wrong on there? We know the recipe, but where do we start? I think you have given the answer, but what is the quick answer to say that? I mean, this is the starting point.
Yeah, I think if you look at the education sector, I think we have a very highly individualistic education system. It's a very exam oriented. I think we have to move out of. I'm not saying that we have to cut down scholarship exams or A-level exams, but then you need to have a better model where, even somebody who doesn't get through scholarship or doesn't get through O-levels or A-levels should have the same capacity to get into the highest level. For example, someone who doesn't get into the A-levels in the right marks should be able to become an engineer. There should be another path. For example, like pathways like we call it foundation programs in other countries, like we should have that. And focus on teamwork, because when you go on a very highly individualistic exam model, you lose your teamwork. So without teamwork, you will never get innovation. So the number one criteria for innovation is that you have to work in a team. So if you don't build that culture in Sri Lankan education system, we will never get the innovation. So I think that's where the changes has to happen.
Yeah, absolutely. Good example is our cricket, right? The teamwork, right? So, well, unfortunately or fortunately, I mean, we are there. I mean, because of that, our thinking, management, and the teamwork that has brought us to the highest level. Yeah. So, okay, I think we have come to the end of the session. We have had 4 presentations ranging from education related to technical education, and then the innovation, the skill, and that kind of aspects, attributes to education, to qualification, to skills and innovation, developing the capacity. And we had 2 presentations on the application of technology. One from Professor Hadikusumo on the use of the modeling and simulation to make the technology applications quite robust, and also Dr. Nutthachai on the development of a new methodology to estimate the concrete composition. So all these 4 presentations made this session very comprehensive, diverse, and also valuable. So I would like to, as the chair, thank the presenters, Dr. T.A. Piyasiri, Engineer Heminda Jayaweera, Professor Hadikusumo, and Dr. Nutthachai Prongmanee for your excellent contribution to this session, presentation, dedication, and being connected till the end of the sessions. And with that, I would also like to thank the organizers and also the audience for being very excited, animated, and contributing to the Q&A session. And with that, we would conclude the session, and looking forward to meeting you once again in probably next year. Thank you. Thank you all. Okay. Thank you.
Now, I would like to respectfully invite the plenary session chair, Professor Rahula Attalage, to present tokens of appreciation to the plenary speakers. Also, I would like to invite Dr. Hirulak Sirivardana, Head of Department of Engineering Technology, to accompany him. May I invite Dr. T.A. Piyasiri to accept his memento, please. Thank you, sir. Thank you, sir. May I invite Engineer Mr. Heminda Jayaweera to accept his memento, please. Thank you, sir. Attalage, sir, please remain there for a moment. We would also like to thank our speakers who have joined us virtually from Thailand, Professor B.H.W. Hadikusumo and Dr. Nutthachai Prongmanee. Your mementos will be sent to you, sir. Now, I would like to respectfully invite the Dean, Faculty of Technology, Dr. Prasanna Premadasa, to present a token of appreciation to the chair of the session, Professor Rahula Attalage, as a pleasant remembrance of his visit to KDU IRC 2022. I would also like to invite Dr. Thelini Wijayaratna, Head of Department of Biosystems Technology, to accompany him. Thank you, sir. On behalf of the organizing committee, we would like to express our gratitude to Professor Rahula Attalage for chairing the session and the respectful plenary speakers for your valuable time and consideration. I would like to request all of you to join us for refreshments. I would also like to announce that the poster session will commence here at 5 p.m. Therefore, ladies and gentlemen, please be seated here by 5 p.m. for the poster session. Thank you. The panel of judges for the poster session evaluation. Professor P.G. Ratnasiri, Professor in Department of Chemical and Process Engineering, Faculty of Engineering, University of Moratuwa. Dr. Ravi Koggalage, Dean, Faculty of Engineering Technology, University of Vocational Technology. And Dr. Hirulak Sirivardhana, Head of Department of Engineering Technology, Faculty of Technology, KDU. May I respectfully invite the judges to the head table, please. As the first poster presentation, I would like to invite Mr. H.M.K.P. Jayatilaka to present his poster.
Good evening, everyone, and welcome to our poster presentation on our research on identification of comfortable zone of an air-conditioned zone room with respect to the room dimensions and the position of its air condition mounted. And we already know that there are several physical parameters which determines the thermal comfortability of an air conditioned room, such as the temperature distribution, relative humidity distribution, and the air velocity distribution. And the aim of this research was to formulate a mathematical model to evaluate the thermal comfortability of an air conditioned room if the respective room dimensions and the position of or the location of the air condition is given. And for that, for the experiment purposes, we have chosen an air conditioned room which is a lecture room located at the Faculty of Engineering, University of Ruhuna. And basically it's a rectangular shaped room, and it is equipped with 2 split type air conditioners. And first we have obtained measurements of temperature and the relative humidity point-wise in its 3-dimensional space, and we have managed to obtain around 800 point-wise temperature values and relative humidity values. And then we have used the MATLAB software to 3D plot those values, and we generate the 3D plot to represent the temperature distribution and the relative humidity distribution. And then with the help of the SolidWorks software, we have modeled that room, and including its 2 air conditioners, and we have performed a flow simulation by defining the boundary conditions for the air conditioner units, and we have simulated the scenario, and then we have managed to obtain the air velocity distribution for the particular room. So then we have finally come up with all the necessary physical parameters such as the relative humidity distribution, temperature distribution, and air velocity distribution, and then we are working on formulating a mathematical model by analyzing the relationship between each physical parameter, and then we are still continuing the research to formulate a mathematical model, and this is what we have done so far, and so we wish to continue formulating a mathematical model very soon. Yeah, thank you.
Right, you are trying to identify comfortable zones of a room, right?
Yes. If the room dimensions and the location of the air conditioning unit is given.
When you say comfortable, what's the measurement? How do you say it is comfortable?
In terms of the temperature and the relative humidity and the air velocity we experience at that point.
3 parameters are there, no?
Yes.
How do you define comfortable? Isn't it subjective, or is there a...
there are certain values such as internationally they consider that 23 Celsius is the most comfortable, and the humidity range should lies between 48% to 52%, such that there are some limits for those parameters which makes us feel comfortable in that zone.
So you use international standard?
Yes.
Is it comparable to Sri Lankan?
Little changes with everyone.
That's why they may define certain coldness as comfortable.
Yes.
But another country may be different.
Yeah, in Sri Lankan context.
That's why when you say comfortable, you have to define what do you mean, right?
Yes.
And so you have put sensors in different places of the room.
Yes. J-type thermocouples, and for the humidity also there are sensors, and we have calculated around 800 points within the space.
800 points?
Yes.
In 3D space?
Or 3D space.
Is that the measurement simultaneous or?
No. After
discrete measurement.
We let the room to come to steady state, and then there is a apparatus with about 12 sensors, and at a time we can obtain 12 readings.
Okay. So discrete measurements.
Yes.
Let me clarify. Actually, in the modeling, you develop the mathematical model using the fundamentals, no? In the simulation, using the existing one, no? Now here, you have used the MATLAB just to measure the temperatures you measured using the things, and then you have prepared the 3D graph using the MATLAB.
Yes.
So what is the model you develop? This is the...
No, it's we just obtained the air velocity distribution using the SolidWorks simulation and the temperature.
What simulator used?
Sorry?
What is the simulator used?
We have simulated the room by defining the boundary condition of the air conditioner, such as output temperature, output velocity, and we have managed to obtain the air velocity distribution within that room, but we still working on determining the mathematical model
for that mathematical model development. Do you use the MATLAB?
No, for plotting the 3D plots of temperature distribution, we have used MATLAB.
Okay, then for the model development, what do you use?
For the simulation, we have just used the flow simulation tool given in the SolidWorks, like Flow Express simulation tool, and there we have to just input the 3D model and define the boundary condition such as the output.
Yeah, you have a separate simulator and then use the boundary condition just to get the air velocity distribution, and
yes,
then you have separate temperature data, isn't it?
No,
With
temperature data we obtain
measurements
just taken from the measuring.
Okay.
Then from the simulation we have just perform it to see the air velocity distribution only.
What is the conclusion?
The aim of this project is
And
to...
from this one, what you can say? From this your measured values and from your simulation, what can you say?
This is in the initial stage, and we have can have an idea about the nature of the distributions. So we are still working on building up a mathematical model based on these observations, but we haven't finished building up a relationship and formulating a mathematical model.
That mathematical model again you are building with the MATLAB, or the because modeling is something else, simulation is something else.
We intend to use MATLAB or any software which might help to formulate a mathematical model, but we haven't still decided which software we might going to use.
Okay, thanks.
Thank you.
What are the variables? What did you vary with your measurement?
Sorry?
What are the variables?
We measured
when you take readings, have you changed anything, any parameters?
No, we have measured the temperature and the relative humidity values in a room which reached steady state.
Steady state only, yeah. So only one measurement?
Yeah, only one state we have. When the room becomes steady state and reach the steady state temperature, we can.
Basically what you are going to do is you just give the boundary conditions and try to develop the temperature profile and velocity profile within the room.
Yes.
Isn't it?
Yes.
When the AC is there.
Yes.
That is what you are going to do now in your model development. Now, Professor Dr. Koglage asking what are the variables.
You haven't changed any conditions. Like your topic says room dimensions and position of AC unit mounted. Have you changed the position of the AC unit?
No, we couldn't.
No.
So it's a fixed position.
For the further experiment, we might have to change and see the variations.
Okay, thank you.
Thank you.
Any other questions from the audience?
I'm curious, like when you use this SolidWorks simulation, so your boundary is the room, then do you use like dividing this boundary into very small parts, like missing, something like missing?
Yeah, in the SolidWorks simulation, Flow Express flow simulation software tool, it comes with the default configuration that we can use directly, and we don't need much complex knowledge on SolidWorks. That we can use the default meshing, and we can adjust the refine the mesh by just sliding the parameters, and we can build the mesh easily once we input the 3D model. As the boundary condition, we use this as an enclosed space. This room we define as an enclosed space, and for the outlet of the air conditioners, we set the output velocity and the output temperature of the air conditioners and let the simulation run.
But from that one, you have not included anything. You have just included the measured temperatures here, no? From your that SolidWorks, that what Dr. Sailesh asked, with mesh size and this control volume kind of thing, no, he's asking. My question also is, now all these things you measured values, not your model value.
The measured values are the temperature distribution and the relative humidity. Then we have generate the air velocity distribution just
using
from the simulation.
Just like, another question, like in your, if we see your diagram, that figure 2, then you can see there is that air velocity is changing. So in that light blue color, so is it reduced air velocity or increased air velocity?
Increased velocity. The
and like
dark blue is
and is the like it depends on the height of the room.
Yeah.
That velocity distribution.
This is only a section of view. For different heights of, we have produced different cross sections with contour lines. The lighter regions has a higher velocity, and the darker regions, that means the air velocity is relatively less.
Relatively less. Okay, thank you. Thank you.
Thank you.
Shall we conclude the Q&A? Okay.
So, you mentioned in Simulink, SolidWorks Simulink. So, what are the boundary conditions which you use for simulation in SolidWorks?
As I told you before, the boundary conditions we set for the simulation is we consider this room as an enclosed space, and for the outlets of the air conditioner, we have set the output velocity and the output temperature of the air coming out of the air conditioner. That's the boundary conditions we set. And the rest will automatically generated within the simulation.
Okay, thank you.
Thank you.
Yeah. Thank you very much, Mr. Jayaweera.
Thank you, sir. Thank you.
Next, I would like to invite Ms. E.B.T. Hansika to present her poster.
Good evening, everyone. I am Tarindhi Hansika. My project topic is secure data transformation in cloud using hybrid cryptography. So, as you all know, cloud is a very well known and accepted data storage that provide many benefits to users with a pay-as-you-go pricing model, even providing storage solutions for massive amounts of data. But can you all guarantee that your data will be secured when you are transferring them to the cloud? When you are transferring them to the cloud servers through the cloud, because they are exposed to the internet. So as a solution to secure the data when they are transferring through the internet, many cryptographic algorithms and encryption techniques have been used. So in earlier days, they have used only one single algorithm to secure the data. And then people have moved on to double encryption. So in here, the file is being encrypted twice using two algorithms, like one after the other. And when we talk about encryption algorithms, there are two types of encryption algorithms, as symmetric and asymmetric algorithms. The symmetric algorithms are mainly used to encrypt a bulk of data. It is very fast, faster than asymmetric algorithms, but it is not that much secure when we are comparing with asymmetric algorithms. But asymmetric algorithms are much more secure, but it requires much more time when compared with symmetric algorithms. So I developed the proposed system offers a method for properly securing data with a combination of three algorithms, AES, ECC and RSA, by increasing the security of data. So in here I have divided that into two parts, as to secure the key and to secure the data. And when we talk about securing the key, the public or private key of ECC and RSA algorithms have been combined to generate a new hybrid public or private key using an exclusive OR gate. So using this hybrid public key, we can encrypt the AES algorithm. So after that, we can upload the file after encrypting the file using that encrypted AES key, and then we can upload the file and the key to the cloud. So if someone wants to decrypt the file and download the file, so he needs to first encrypt the AES key. So in order to do that, he needs to decrypt the AES key using hybrid private key, and then he can decrypt the file using that decrypted AES key. So this hybrid key generation of ECC and RSA algorithms are used to increase the security and strengthen the key, while this AES algorithm is used to encrypt a large volume of data easily while reducing the time complexities of the proposed system. So the proposed system will increase the security as well as it will reduce the time complexity. Thank you.
Thank you very much for the presentation. My first question is how this method is different from the current cryptographic methods that is been using.
Yeah, like there are many different methods. This method I developed like by going through many research papers, and I need to secure the data, and also I need to make that method more efficient. Like we need to balance the security and the time. So that's why I went through this method.
So when compared with the existing cryptographic methods, how efficient is your proposed method? Do you have any idea?
Yeah, I can't say that because I'm still on the implementation of this part.
So what is new in your method? You have combined two encryption methods.
No. Like first, there are three algorithms actually. ECC, RSA and AES. AES is a symmetric algorithm. So I can use that symmetric algorithm to encrypt a large bulk of files. But I cannot use ECC and RSA to encrypt a large files. So I used ECC and RSA to encrypt the AES key. So
combination of both.
Yeah.
So that's what I asked. Not only single algorithm, but
combination of three
algorithms. So when doing that, what is the advantage?
Yeah, the advantage is it will be secured actually.
Very secure.
Yeah, very secured. Yes. But I used AES to reduce the time. Because if I use only ECC and RSA, I cannot do that because I can encrypt 1 kilobyte files, but I cannot encrypt very large files. It will take so much time. So I used AES to reduce the time. So using ECC and RSA, it will only encrypt the AES key, not the file.
Not the file, only the key encrypted using two algorithms. Right. ECC and RSA. Yeah. But for the whole data you use
AES.
AES. Yeah. What was the existing method?
Yeah, actually there are many existing methods. There's one paper regarding XOR gate, to generate the XOR gate. So they have told that the key is much strength. That's the only part they have told. So I combine this with AES and generate this methodology.
So except the key, data, it is the normally used one method, no?
Yeah, encryption. Normally one encryption.
But your method, you are focusing only the security of key.
No.
You use two algorithms for the key.
Yeah, encryption. I use two algorithms for the key.
Not
so
the data.
Using that key, I encrypt the AES key.
Yes.
So using that key, I encrypt the file.
Yeah. You need the key to encrypt, no?
Yeah.
Encrypt and decrypt.
Yeah.
But your method applied only for the key.
Both
the
key and
combination of two algorithms, right?
Yeah.
You're not sure about it.
No, I'm using those two algorithms to encrypt the key,
Yes.
but I'm also like encrypting the files.
But encrypting files, it is
Yeah,
already
it's
existing
already
method.
existing.
It's
Yeah,
not
yeah.
your invention.
Yeah, yeah.
Your one applied only to
Yeah, key.
key.
Yeah.
Right?
Yeah.
Have you practically applied this one or tried to apply this one for a
Yeah,
set of data?
Yeah, I'm going through the XOR part. Actually, right now, I have just encrypted using ASA, RSA, and those things, and I tried uploading into the cloud. That's totally okay. And now I'm on the implementation part of XOR.
Encrypting and decrypting both ways?
Yeah, both ways. Fine.
Okay.
Now, you have secured key, and there are many different ways of generating keys, right?
Yeah, using the algorithms, they are the algorithm differs to...
So you can change the complexity, maybe for example, length of the key.
Yeah.
Right? To increase the length of the key, maybe
Yeah,
secure.
it will be secured, yeah.
So, your one, you have applied to secure the key.
Yeah.
Mainly.
Right?
Yeah. So have you compared it with any other existing?
Still
Not yet. No?
Not yet.
It's just a proposal, right?
Yeah.
In your poster, other two are your supervisors?
RGC Upeksha and Professor Tushara Veerawardhana.
They are both supervisors?
Yeah, they are both supervisors.
You are the only author, no?
Yeah.
All right, good. You said you referred many references. You have only mentioned 2 references just because of the space limitation, or how many papers you?
Yeah, I went through like 40 papers.
Good.
Any other questions from audience? So again, if I ask the same question, hybrid key, your conclusion said hybrid key generation increases the key strength.
Yeah.
As well as execution time. How does it improve the execution time?
I changed that one. It will like reduce the execution time.
Yeah. How does it reduce the execution time? That's my question. I improve strength clear when you do the key encrypting, when you combine these two. But how do you reduce the execution time?
I have to check that with other algorithm.
You have mentioned your final conclusion. When you present something, you should know. When you say such a statement, at least you have to compare with the existing one and say this is faster than this thing and some kind of justification.
Yeah, you have to go through the implementation to do that.
Okay, thank you.
Okay, thank you.
Next, I would like to invite Ms. DSGGC Swarna Tilaka to present her poster.
Good evening, everyone. I am Dr. Swarna Tilaka and I am an MP student of Bombay University. So today I am going to present one of my research findings. It is about evaluation of growth, yield and nitrogen losses from leafy red onion cultivation with different fertilizer practices in Kalpitiya Peninsula. So as you all know, Kalpitiya is highly productive agricultural areas of the country. Due to the high soil permeability and poor soil fertility in sandy regosols in Kalpitiya area, farmers are applying excessive amount of fertilizer expecting better yield from this infertile sandy soil. So the dominant soil type in Kalpitiya is sandy regosols. due to the prevailing dry climatic condition in Kalpitia area, intense irrigation is common. High soil permeability, heavy application of fertilizer and intense irrigation causes high soil permeability, high fertilizer application and intense watering causes significant loss of applied nitrogenous fertilizer through leaching that results in the contamination of groundwater. So currently a gradual accumulation of nutrients in groundwater has been taken place and the groundwater is in Kalpitia is becoming more polluted with high concentration of nitrate. So the aim of this study was to evaluate the effect of different fertilizer practices on growth, yield and nutrient leaching in leaf red onion grown in Kalpitia. So let's move on to the methodology. This research was conducted in Kandakuli agricultural land in Kalpitia area. Lysimeters were installed 9 cm below the soil surface of separated plots. Compost was applied at the rate of 10 tons per hectare for both treatments. So there were 2 treatments. T1 was farmer use rate of fertilizer and T2 was Department of Agriculture recommendation. So these 2 treatments were replicated 3 times in 7.2 square meter plots. Jaffna local red onion bulbs were selected for planting and watering was done 2 times of the day, early in the morning and the evening. So leachate was collected from each replicates at weekly intervals and leached volume was measured. Nitrate and ammonium concentration of both leachate and irrigated water were analyzed using iron selective electrodes. After 48 days of planting, leaf red onion was harvested and yield was recorded. The data was analyzed using 2-key test using R statistical software. So let's move on to the results. There is a significant difference between yield among T1 and T2. T1 was given higher yield with compared to the T2 because this may be due to the split application of nitrogen fertilizer throughout the growing season for T1. When talking about the nitrate concentration, both treatment shows higher nitrate concentration than WHO permissible level for drinking water. Normally WHO permissible for drinking water for nitrogen in nitrate was 50 milligrams per liter. So nitrate concentrations fluctuates over the time. So when talking about the nitrogen leaching percentage between treatments, T1 was given high nitrogen leaching percentage than T2. Irrigation and intermittent fertilizer application calls for higher nitrogen leaching percentage in growers' use rate. So when concluding the findings of my study, the concentration of nitrate in leachate is above the World Health Organization standard of drinking water irrespective of the treatments. So there is a necessity for a novel fertilizer management approach for reducing nitrogen leaching in red onion cultivation in standard episodes. So thank you very much for your kind attention.
What have you measured? Is it the water content?
Yes, sir. Here I analyzed both leaching and irrigated water.
In this farmland, no? Onion growing. In this farmland close to this?
Yeah. Actually, this land is located in Kandakuli. In Kalpitia area.
So when you are taking water samples, what are the test things? You applied this?
So here we compare 2 treatments. T1 was the growers' use rate that currently practiced in Kalpitia for red onion. And second one was the Department of Agriculture recommendation. In addition to the DO recommendation, here I used biochar. Actually, it's the soil amendment. It has capacity to reduce nitrate leaching.
Is it the same location or 2 different?
No, it's the same location.
Same location.
Yeah. So before doing this cultivation, we have already established lysimeters. It's a spiral-like structure.
Have you measured this nitrate level in groundwater in another area, different geographical area as a comparison?
Yes, madam. I measured nitrate concentration in Kalpiti Peninsula. There were 50 locations.
As a different, it comes to a different geographical area like probably a central province or not central province?
No, madam. Only the Kalpiti area.
What is the method that you use for?
Sir?
What is the method that you use to measure the concentration, nitrate concentration?
Sir, there is a
chemical method or a sensor?
No, sensor method. And selective electrodes were used for this.
Okay.
The separate electrodes, nitrate and ammonia. Okay. Before using, we have to calibrate it. And
so your findings, what is the outcome?
So we need a novel fertilizer management system for Kalpitiya.
Right. Why you are telling so?
So, actually WHO permissible for drinking water for nitrate is 50 milligrams per liter. But in this field it exceeds normally 200 ppm.
Your both tests exceed this limit, right?
Yes, sir.
So what is your justification whether you use this compost or not? Still the...
But sir, by using biochar we can able to, here we can reduce it.
But both samples, it is saying...
but there is a significant difference in nitrogen leaching percentage. By using biochar we were able to reduce it.
T1 I get 78% leached nitrogen.
So basically you wanted to find out once you apply the fertilizer, how will it goes to the soil and isn't it? Whether with that for example, in our problem is once you apply the urea for the normal paddy land, normally that will not goes to the soil. Sometimes with the water it will isn't it?
Yes, sir.
You want to find out what is the most effective method of distributing your fertilizer, no?
Yes, sir.
Into the then you use the different mixtures with the biochar without biochar.
Yes.
What the type of biochar you use?
Paddy husk biochar.
Paddy husk. So you
burn paddy husk.
Yes.
Yeah.
Pyrolysis.
Yeah.
And then you could not reduce. You could reduce some nitrate concentration because of that.
Yes, sir.
You did the sampling, this plot area, in which locations you make a weekly, no, you got the sample?
No, sir. Leachate samples were collected weekly intervals.
Leachate mean you?
So before the cultivation we have installed lysimeters. It's a barrel-like structure. It can collect water. So by giving artificial pause, that means I use a water pump to collect leachate.
All right.
Then I did the analysis. I collect the leachate and
the same depth of the leachate?
Yes, sir.
Same depth or different?
Same depth, sir. Because it's a barrel-like structure now. It can hold water.
Right.
So these two samples, one you have used fertilizer, urea and TSP. The other one biochar, right?
Yes, sir.
Have you used any other water sample without any of those in that area?
Yes, sir. Before this cultivation, I took some initial water samples and measured the nitrate and ammonia concentration.
It's not indicated here.
Yes, sir. But I include those things in my paper.
Because normal water concentration we need to know.
Yes, sir.
Because we don't know whether fertilizer has increased or decreased or whatever.
So normally nitrate concentration in irrigated water was 7.8 ppm.
Very much less than this.
Yes, sir. That's why here here I consider both irrigated water and leach input nitrogen fertilizer as input sources of nitrogen. When calculating leach nitrogen percentage, leach nitrate amount was divided by the total input nitrogen. So both fertilizer and irrigated water was considered as both input sources.
But your concentration units are kilogram per acre, no? Now you told the ppm, no, with the normal water samples. Now you are given kilogram per acre, isn't it?
Yes, sir. Sir,
So
I know the concentration of the leachate and I know the leachate volume. By multiplying it, it comes total amount, milligrams.
Like a sample should be milligram per liter, per acre. Is it the unit that you can...
Per acre you have put this amount of fertilizer, no?
Yes.
But where you collect samples, how many samples you collect from an acre?
Area of the sampling unit is 7.2 square meter.
So each 7.2 square meter you collected one sample?
Samples.
How many samples?
Each treatment has 3 replicates. No? There are 6 sampling points. There are 2 treatments, T1 and T2.
Yeah. T1, how many samples you have collected?
3 samples.
3 samples?
There are 3 replicates. For T2, there are another 3 replicates.
Area of that one replicate is 7 meters.
7.2 square meters. The plot size, the area of the plot is 7.2 square meter. At the center of the plot, the lysometer was installed, and I do the cultivation.
Another one is like your topic is the evaluation of growth, yield, and nitrogen losses. And in conclusion, you did not mention regarding the yield of the red onion. So from your graph, if you see, then if you use fertilizer T1, then it seems that harvest yield is higher than the
T2.
Than the T2 fertilizer, right? And but like in the conclusion, you did not mention so in terms of the harvest yield, then this T2 fertilizer is better.
T1.
Sorry, T1 is better.
Yes, sir.
But in the case of that nitrate leaching, both fertilizer are not good. Means the leaching is higher than the WHO standard level.
Yes.
And another thing is like you have mentioned evaluation of growth. Then how did you evaluate growth? Growth means.
So I measure the number of leaves and height of the plant. Actually, here I didn't include it.
And height of the plant and the
number of leaves.
Number of the leaves.
Number of leaves per week.
Okay. Then another one is like in the literature, like so why did you choose only like red onion? Like are there some other
red
vegetables?
onion is the most cultivated crops in Kalpitiya. It's the major cash crops. Second one is chili.
Okay. Thank you. Thank you.
Thank you very much.
Thank you.
Next, I would like to invite Ms. SPD Thivaka to present her poster.
Good afternoon, everyone. I'm Thivanka Samaravikrama from University of Colombo Science Faculty. I did my research in the field of sustainability, and here I prepared a modified green building rating system to evaluate the sustainability of residential apartments in Sri Lanka. And here I selected this topic because until now there is no unique system to evaluate the sustainability of apartments in Sri Lanka. And also until in the present there is a boom of apartment construction in the world as well as in Sri Lanka. There is a boom of apartment construction in the world as well as in Sri Lanka. And because of that, I decided to develop this modified rating system to evaluate the sustainability of residential apartments in Sri Lanka. And here, this is the methodology of my research project. It goes with 2 objectives. Under the first objective, I selected 3 Green Sri Lankan rated apartments as 3 case studies to analyze the points that had been fulfilled during the evaluation for Green Sri Lankan certification. And under the second objective, I conduct a comprehensive literature review to identify new ideas that can be introduced as criteria in the modified rating system that I wish to be developed. And finally, I suggested a category and criteria amendment for the Green Sri Lankan rating system for the built environment. Apart from these research gaps I previously described, while reviewing the literature, I found that in most international green building rating systems, they do not equally consider these 3 sustainability pillars. It means the environment, social and economic pillars during the point distribution in their rating system development. It means there is a bias toward one or two pillars of sustainability in their rating system that cause heterogeneity among these subsets. Because of that, I decided to check whether is there any sustainable subset heterogeneity in the Green Sri Lankan rating system as well. I selected this Green Sri Lankan rating system here to analyze because it is the first local green building rating system in Sri Lanka developed by the Green Building Council of Sri Lanka in 2010. And I suggest category and criteria amendment for modify this rating system with the special focus on residential apartments in Sri Lanka. And the point distribution analysis of this selected Green Sri Lanka rated apartment is done using the proposed method in this table 1. Here, this method was explained using 1 category of the Green Sri Lankan rating system, materials, resources and waste management. Here, when criteria represent 1 or more pillar of sustainability, the points allocated to such those criteria were equally divided into those 2 subsets as you see in this table 1. And under the results and discussion, I mainly discovered that there is a sustainable subset heterogeneity in our Green Sri Lankan rating system by considering the point distribution percentages in these 3 selected 3 Green Sri Lankan rated apartments. And because of that, we need to avoid this heterogeneity but achieving the exact 33.3% point distribution for each subset. It's somewhat difficult. Because of that, I introduced new point distribution percentages as 40% for environment and 30% for both social and economic sustainability. And these proposed point percentages were adopted during the modified rating system development. In the table 2, you can see this point distribution of this proposed modified rating system for residential apartments. Here, we introduced new category called disaster risk reduction, and another 3 new criteria was introduced under this indoor environment quality category as enhanced compartmentalization, air purification and enhanced acoustic performance. And another 2 new prerequisites were introduced here as compartmentalization and interior moisture management. And here you can see these point percentages 40.6 and 31.3 and 28.1 percentages were allocated for environment, social and economic pillars respectively in this modified rating system, and the proposed point distribution percentages were almost achieved here. And finally, this study concluded that the sustainability practices in residential apartments in Sri Lanka need to be further improved by providing more weightage to social and economic pillars. And I also recommend to amend our current Green Sri Lankan rating system by incorporating this suggested amendment for better evaluation of sustainability of residential apartments in Sri Lanka. Thank you for listening.
How do you collect data?
So I requested from the Green Building Council of Sri Lanka.
So there are readings you took and analyzed, no?
The apartment needs to give a report for them while during the rated. Then I request those reports from the Green Building Council of Sri Lanka with the permission. Then I find the point distribution percentages using that data.
So based on that data, you draw those charts. What is this ABC in figure 1?
So the figure A is the normal sustainability model. Here all three sustainability subsets are equally considered. In figure B and C, it represents the models with subset heterogeneity.
Is it based on the collected data or these are existing models?
The normal sustainability model is the existing model, and based on my data, this is the model I gained from the
that means B.
B and both B and C. It can be changed according to the the model can be changed according to the apartment, because some apartments consider more social sustainability practices than economic practices, and some are consider more economic sustainability practices than social sustainability practices. That's why I put those as examples.
How are you going to do that? Now you have existing data collected by Green SL.
Green Sri Lanka.
Right? Green Sri Lanka. So that is from certain apartments, right? Now if you are, for example, if you are going to apply a model A, so what are the suggestions for those apartments? Are you going to give suggestions, or is it for new apartments?
I give suggestion for amend the current Green Sri Lankan rating system
so change the rating system.
To amend the rating system.
Not what they are doing.
They mostly consider about environment sustainability, and this social sustainability is less considered. That's why I need to develop a modified rating system for apartments.
So you are changing rating system according to say this is good. No suggestions for the, for example, waste management or whatever.
Yeah, I suggest disaster risk reduction as a new category. And on the indoor environment quality, I suggest 3 new criteria: enhance acoustic performance, enhance compartmentalization, and air purification. Because air purification is really important these days, because after COVID-19 pandemic, the US Environment Protection Agency stated that the coronavirus can be spread throughout the building heating, ventilation, and air conditioning systems. That's why I think it's important to include in the rating system that evaluate residential apartments.
So you think like that, or any justification to suggest like that? Or you think if you do that,
I did the literature, separate literature review. I do not include it here because of the space limitation. I refer 50 or 60 articles to
so literature they have done such kind of changes, and you are suggesting it.
Yeah, considering this literature, I suggest these new modifications.
So under each category, as an example, say management, do you suggest what are the points that you have to consider under that management as well? You know, the management is the title, and under that management, what kind of things that you are looking for? Have you suggested that as well?
I do not change the criteria under management category.
I mean, the categories that you have proposed, like disaster risk reduction.
And for disaster risk reduction, we can mainly do it using two main steps. One is the disaster risk reduction using the passive design principles in the green building rating system. As example, like shear walls as example, it can for huge winds, it can shear walls are important for withstand the huge winds. Likewise, disaster risk reduction, and I proposed 3 or 5 categories. I exactly don't.
So in the criteria here, it says recycling 75% of the construction waste. Is it correct?
Sorry, sir.
75% of construction waste recycle?
So it's a criterion in the rating system developed by the council.
But normally, you know, at the moment, I think Sri Lanka doesn't have this construction waste management technology. And what they do is they discharge to another place.
This
They
criteria.
recycling 75%. I'm not sure. I think civil engineers are there. Construction. But do you know that you work in the industry?
So have you referred any foreign rating systems such as LEED for USA and Green Building Council of Indian Green Building Council? There's a separate rating system, and maybe BREEAM from UK. So have you referred any foreign rating systems?
Yeah, I refer to local green building rating systems and one foreign green building rating system, LEED for residential apartments. And another one is the Blue-Green Sri Lankan rating system introduced by the RDA, but it is not in practice now. Then I compare those 3 rating systems. But I include the only Green Sri Lankan rating system here.
Okay, so in your research, have you focused on, for an example, in a rating system, there should be a marking criteria. For an example, for the previous question around, let's say, for the construction waste, if the project saves, let's say, amount of 50%, then there should be a marking. Like we are giving 3 score, score number 3, or maybe we can give score number 2 if it's less than that. So have you identified into that level, or you are just defining the context, like social, economical and other aspects need to be changed? Is that so, or have you identified the criteria as well?
I identified the criteria.
Okay.
Before you evaluated disaster risk reduction, like what kind of disaster risk reduction, like fire, what are the
it can be floods and high winds, floods, high winds, storms like this. I do not evaluate in deeply. I just it's a category, and there are 2 criteria under this category. We need to initially reduce the damage for the building, and secondly, we need to increase the building resilience using passive design principles.
This like a different disaster. If you consider more disaster, different kind of disaster, then the your that final conclusion that evaluation rating will be changed. Suppose like you mean like in your disaster risk reduction, so you choose like tsunami or flood or storm. So when you choose those disasters, will it affect your final conclusion?
No, sir. I don't go into such deep.
Thank you.
Thank you very much.
Faculty of Technology commends the contribution made by all poster presenters. While the judges decide the best poster presenter, I would like to invite you all to watch the video about KDU.
Dictum engraved on the coat of arms of the eminent personality, late Prime Minister Right Honourable Sir John Kothalavala, would become the founding cornerstone of the prestigious General Sir John Kothalavala Defence University. Nestled in the heart of Ratmalana, Sri Lanka, the university, a beacon of defence-related higher education, was a labour of love for the General, whose life's work was to protect his country and entice thousands of others to do so. In the beginning, the General Sir John Kothalavala Defence University, now known as the KDU, was conceived as a tri-service academy and was referred to as the KDA. The academy at the time was tasked with upholding the roles of the three armed forces. Graduates belonging to each military discipline were skilled with the knowledge to effectively coordinate on ground, at sea and in air. With the Sir John Kothalavala Defence Academy Amendment Act, the Academy was empowered with the right to award degrees of its own. With the renaming in 2007 as the General Sir John Kothalavala Defence University, the Academy commenced its transformation to be a fully fledged university, becoming the only establishment of its nature to impart defence, diplomacy and security-related education in Sri Lanka. The university, with its world-class standards, systematic innovation in line with global practices, and local and international student body, places emphasis on the unification of fundamental ideas. These pillars have world over been successful in the development of countries, their defense mechanisms, and enhancing the civilian workforce. With the discipline of a military training establishment and the commitment for knowledge dissemination, KDU not only provides a platform for those who want to contribute to national security and development of one's country, but it also imparts high-quality education in an array of disciplines such as engineering, law, medicine, management, social sciences and humanities, allied health sciences, built environment and special sciences, computing and IT, technology, criminology, and police science. In its forward march of 4 decades, the KDU has produced alumni who have made brave sacrifices for the security and the territorial integrity of the nation, and earned gallantry awards for serving the country with distinction. Many amongst them have made the supreme sacrifice for the motherland. Since the end of the war, those who pass out from the KDU operate in the tri-services and elsewhere as disciplined and committed leaders who continue to serve the national interests of the country. The KDU is home to multiple faculties and disciplines that empower and provide a range of choice to both tri-service office cadets and day scholars. Day scholars whose focus is not to pursue a military career are also able to learn on campus while truly understanding the dedication of their counterparts, the tri-service office cadets and police officers. This leads to a harmonious environment between civilians and the military, both on and off the campus, due to their shared experiences at the KDU. Addressing national issues with brain drain, the KDU offers Sri Lankan youth an opportunity to take on fields of study that would have previously been sought out in other countries. The benchmarks.
Thank you. The judging panel has decided the winner of the poster session. May I cordially invite Professor P.G. Ratnasiri to award the certificate to the best poster of the technology track of KDU IRC 2022 and Dr. Thilini Vijayaratna to accompany him. We are delighted and proud to announce the winner of the poster session. The best poster award goes to Ms. E.B.T. Hansika for the title of Secure Data Transformation in Cloud Using Hybrid Cryptography. We congratulate Ms. E.B.T. Hansika for her achievement. I cordially invite Professor Ratnasiri to remain on the stage to give away the certificates to the poster presenters. Mr. H.M.K.P. Jayatilaka, Ms. E.B.T. Hansika, Ms. D.S.G.G.C. Swarnatilaka, Ms. S.P.D. Tivanka, Thank you, sir. Now, I would like to cordially invite Dr. Sailesh Shrestha to present the token of appreciation to the panel of judges and Dr. Thilini Vijayaratna to accompany him. May I invite Professor P.G. Ratnasiri to accept his memento, please. May I invite Dr. Ravi Koggalage to accept his memento, please. Dr. Hirulak Sirivardhana to accept his memento, please. Thank you, sir. We have come to the end of the day one. On behalf of the Faculty of Technology, we would like to express our gratitude to everyone who participated. Thank you all for your attendance and wish you a wonderful evening.